got Professor Kipping here. Thank you so much for your time. It's really an honor.
My pleasure. It's great to be on here. Thank you, Tommy.
So what originally got you into, space, looking at exoplanets? When you were a kid, was it something that you had seen? Was it something, what sparked that interest that, okay, this is where I'm going to go?
Yeah, it's deep. It runs into my blood. When I was 5 years old, I remember my parents bought me this book just covered with facts about space. It was the planets, Jupiter, the moons. And I remember just studying that book and learning the masses, the orbital radii, everything I could about them. And it just started a lifelong fascination with what's out there. The infinite possibilities just always captured my imagination. I mean, it felt like we understood so much in our own world, but out there, it was just a giant question mark as to what could be out there, whether we're alone. And of course, I found a fascination with science fiction, a big Star Trek fan growing up, Star Wars, all of that, couldn't get enough of it. And as I was at high school, I think I switched gears. I actually started to become more interested in physics rather than astronomy, which obviously is naturally connected. And I remember when I was like 13, my mind was blown by the idea that there was particles passing through your head every second, and like 1 million neutrinos are passing through your fingertip. And that just was like, wow, like what's going on? Like you just see the world differently when you realize that. So I thought I was going to be a physicist, and I trained as a physicist. But then when I was at college, I started to realize that it was astronomy where my first love was as a child, and also where the greatest potential in the current era was for discovery. We still know of less than 0.0001% of the universe. There's 100 billion stars in our galaxy, and so there's only 10 billion people we're not even there yet, but coming up to 10 billion people on the planet. So each of us can have 10 stars each that we could just study our whole lives. They're just your 10 planetary systems, right? There could be hundreds of planets there, and you get to study all of them just for you. And that's just our galaxy.
The ones that we can really see, right? In our galaxy.
So the scope, the vast unknown is just unlike anything else.
And then you just went crazy with it.
I guess it was just, I was lucky to be able to follow passion. I mean, lots of people have a passion for astronomy, and very few of us get to pursue it professionally. Every year, I'm a professor at Columbia, and every year there's about 60 to 70 undergraduates that write to us asking for research projects. These are astronomy students, engineering students, and there's only about 13 faculty in our department right now. So that's just too much. We can't handle that many students. On top of that, we have high school students writing to us. I have students from China, Japan, South Korea. I get dozens of emails every week asking for mentorship. The thirst amongst young people to study astronomy, it's overwhelming. In fact, if you look at national statistics, the number of US in the United States astronomy majors, people who declared astronomy as their major degree, has increased by a factor of 2.2 over 10 years. Wow. Whereas in all of the STEM fields, it's 1.4.
Wow.
So astronomy is outstripping even other science, technology, medical engineering fields. And I don't have a good explanation for it, but it's great because obviously I'm passionate about it.
Right, and it's great to hear. I've been into it since I was a kid too, because I would look up. I mean, look at the ceiling and the things I have laying around here. I would look up and just be like, what is up there? Yeah. What is going on? And when you think, like, is this a simulation? That's how I always thought. I go back and forth in my head, like, is this a simulation? Is it not a simulation? Because it just seems so weird. And then between, like, I was talking about Robert Beto, and then, Greer, Avi, some other ones. What do you think? Do you think there's any possibility that this is all simulation?
It's definitely possible. I actually wrote a paper about that, and I think it was, to my opinion, it's been a little bit oversold. Elon Musk famously said on stage or in a Q&A once that he thought it was like 1 billion to 1 odds that we don't live in a simulation. I'm not sure if his position has evolved since then, but that was a few years ago. And I thought that was probably overselling it a little bit. I wouldn't give, because that's almost certainty at that point. I wrote a paper about this and said, well, it really comes down to whether it's possible for computers to ever simulate all the fidelity of nature that we perceive. Can it simulate our minds? Can it perceive our perception of the universe? And that's an open question. It might be possible. But in science, we try to be, data-driven, evidence-driven, and we don't know with assuredness that's possible. So we have to just be a little bit agnostic about that. It's certainly viable, but it's and certainly this era. I mean, there's a compelling argument that this era would be a particularly interesting era to simulate. Right? We seem to be. There's so much craziness going on in the world right now that if you're going to simulate a time of the most complex social economics, a society struggling to mature into maybe something that could be more stable in the future, this might be the era that you'd be most fascinated in watching that maturity happen. So I totally get the argument for it as to why this might be the time to simulate. But I remain agnostic about it. And, it's been said many times, it frankly doesn't change much, does it? I mean,
no,
we're all simulated.
Here, right. If somebody's hitting the ABC button, it doesn't really matter, But when Beto had said space never began and never ended, that was just something that stuck in my head. And then that's when I was like, well, how could it never begin and never end? Do you feel like that too? Like space never began and it never end? Not the universe, space itself.
Yeah. Certainly space itself probably never ends. I think that's I think a lot of astronomers and cosmologists are coming around to that perspective. When you look at the universe, obviously there's a furthest distance we can see, which actually happens to be about 90 billion light years away. Even though the universe is 13, 14 billion years old, we can see a little bit further than that because the expansion of the universe is so rapid. So the furthest things we can see are 90 billion light years away. But that doesn't mean the universe ends at that point. Presumably it just keeps going and going. And we can even measure the curvature of space-time, and it seems to be very, very flat, which implies that it does just keep going forever. So it may be there's an infinite universe, and that's a jarring thought because it means there's an infinite number of potentially everything, right? Especially if it's not just infinite space, but infinite matter populating that space. Then you have infinite versions of us having this conversation, infinite versions of the listeners right now listening to this, but maybe just slightly differently, but then also exact duplicates, and an infinite number of those. And that's difficult.
That's even starting to blow your mind. Yeah. Talking about, and here's a guy, So, and that would be like dimensions where you and I are sitting here right now, but in another dimension, I'm 6'6" and fat, and you're 5'2" and skinny.
These aren't even other dimensions. This is just imagine this tabletop is space time. This is just continuing out in all directions forever and ever and ever. So we're all existing in the same space time plane, if you like. On top of that, this is what we call the level 1 multiverse, as Max Tegmark, the physicist, often likes to call it. On top of that, there could be other types of multiverses. In addition, there's the possibility of, as you said, like other dimensions or other universes which could collide with ours. Then on top of that, there's this quantum type of multiverse where basically every decision you make is kind of attributed to Everett, a quantum physicist. He had the idea that it really does split off into different universes. Every time an atom has to make a decision, if you like, as to whether to decay or not, both events happen, and it sort of lives in a superposition of those two simultaneously. And so one interpretation, a very initially controversial interpretation, but lots of my colleagues are coming around to it now, is the idea that all of those things happen all at once. And so every little decision, every little possibility is also kind of almost sat on top of us. So that's not this table. It's almost like a ghost-like version of this table that almost lives slightly offset from it. So it's wild. It's if you spend too long thinking about this, you go down the rabbit. I read, I don't know if it was that exact paper, but a similar one, and what I had taken from it, like a grid. So if I make this decision to move this right now, I pick that on the grid, and each and every decision, I guess would be in like the space-time continuum, then that would perceive, or outcomes would be different in different situations. Yeah, I guess when we say decision, we have to be a little bit careful with that word because it depends. In the quantum theory, it's really talking about quantum level events, and so what that really means is, as I said, like the example of atomic decay is a good example. The famous example of this is attached to Schrödinger's cat, where you put something that's going to decay into a box, you put a cat inside it, and if that thing decays, it triggers maybe like a bottle of poison that would open up and fill the box and kill the cat. And so in this famous thought experiment that Schrödinger proposed, the cat is both dead and alive because there's a superposition, a quantum superposition mathematically you can show of these two states. And so, you know, for decades, people have been arguing about what that really means. Does it mean that the cat either actually collapses this decision, so maybe only one thing happens, it's the cat's observation of it that actually forces reality to choose one path, or do both paths happen and we have this superposition on top of each other where both realities are happening at once? And it's almost a philosophy at this point. And quantum physicists usually shy away from discussing the philosophy and the interpretation, but it's something I think we're realizing has deep implications and we have to wrestle with.
Maybe they're afraid to end up in the nut house if they start thinking about it too much, you know, when you go through it. What are your thoughts on the Big Bang? You know, some say, you know, Big Bang happens every 2 seconds, but do you, you know, as say people watching this, when you think of the Big Bang happened and bam, here we are in some way, shape, or form. Yeah. Well, what's your perspective on the Big Bang? This episode is brought to you by Manscaped.com. Breaking news, Manscaped now sells beard products. That's right, they are once again revolutionizing men's grooming with brand new Beard Hedger Pro Kit. From a beard trim to a fresh shave, the technology behind Beard Hedger Pro Kit allows you to shave your signature beard look. Now you can finally use Manscaped products to make your drapes match your carpet by going to manscaped.com and using code MSCS MEDIA for 20% off and free shipping. No one likes a weird beard, so say goodbye to all the stubble trouble with Manscaped's Pro Beard Kit. It all starts with the Beard Hedger. This thing is a monster of fixing faces. First off, this cordless trimmer has a rotary wheel that gives you 20 hair cutting lengths, all with one guard. No more messing around in drawers, this color one, that color one, all with one guard. Plus it's waterproof, so you can shave in the shower and avoid all that hair in the sink. The Pro Kit doesn't end there though. First, there's the beard shampoo and conditioner. You need to remember your hair is different. Next, Manscaped's beard oil. Cap it off with beard balm. The Pro Kit also comes with 3 different gifts: a beard brush, comb, and scissors to ensure your beard is ready to impress. So get 20% off and free shipping with the code MSCS Media at manscaped.com. That's 20% off and free shipping at manscaped.com. Use the code MSCS Media. This episode is sponsored by ZBiotics. What is ZBiotics Pre-Alcohol Probiotic? The ZBiotics Pre-Alcohol Probiotic is a genetically engineered probiotic you drink before drinking alcohol to avoid that rough next morning and get back to living your life. PhD scientists invented it because they know the real problem is not dehydration. It's a toxic byproduct of alcohol, and ZBiotics Pre-Alcohol Probiotic is the only product that breaks it down. Just remember to drink responsibly and plenty of rest too. Every time I have ZBiotics before drinking, I'm amazed at how good I feel the next day. ZBiotics is a must-have for me because it means I'm still going to make my daily workout even if I have a few drinks the night before. That's important to me. You can get ZBiotics for 15% off your first order using my code MSCS Media at checkout. I recommend getting the 6-pack. That's what I got. It's a great deal. You have a couple extra to share with friends. Go to zbiotics.com/MSCS Media. That's Z as in zebra, biotics, BIOTICS.com/MSCS Media, or scan the QR code on the screen right now and get 15% off your first order.
It's certainly a leading theoretical idea as to how the universe began. It explains an enormous amount of observational evidence. Obviously, we live for sure in an expanding universe. That's something we can measure with high confidence. In fact, not only do we live in an expanding universe, we live in a universe that's expanding ever faster. The rate isn't just constant, it's accelerating. There's actually a Nobel Prize awarded for that. And that's what we think this thing called dark energy might be responsible for, sort of forcing the universe to almost explode at a slow rate. And so Big Bang is just sort of reversing that idea. If you reverse the clock back, there's presumably a point where the density of galaxies, of stars, of matter within any given unit of space, within this room, say that amount of space, that's going to increase until eventually reach an infinity. And that's where Big Bang Theory really gets stuck, because infinities is where we don't know what to do. The math kind of blows up at that point. So it's really a statement that the universe expanded from a point of extremely high density. What came before that, what triggered that, is, again, like a huge open question. and maybe not even one amenable to science, because science is fundamentally based on the idea of collecting evidence, of testing your theories, of looking at observations. But here, there are no observations of before the Big Bang. How can we possibly have data back then, unless we invent a time machine or something, have a ability to go back? At the moment, we're kind of stuck. There are some ideas that if there was a previous universe, like a cyclic universe, Roger Penrose, a physicist, is very keen on this idea, there could be echoes of that previous universe that were imprinted into the Big Bang, but we don't see anything for that. So it seems like the universe is extraordinarily uniform. You look in every direction, and more or less looks the same. There's no special parts of the universe. There's galaxies everywhere. There's galaxy clusters everywhere. There's stars everywhere. And in fact, if you map the cosmic microwave background, which is basically the microwave radiation that came off, that's left over from the Big Bang, that is extremely uniform in all directions. And that's very difficult to explain unless the universe began as one very small thing that could have reached equilibrium with itself, and then from that equilibrium exploded into this vast universe that we see. That's the only way you can really explain how you get the uniformity you get. And then on top of that, you have inflation, which is the idea that even with Big Bang, that's probably not enough. You have to have this very, very, very rapid phase of expansion where the universe itself is expanding faster than the speed of light in very early times. And this inflation kind of leads to the ideas we were just talking about of the multiverse, because if you have an inflation event here, which leads to a very rapid expansion, it presumably is not happening everywhere all at once, or that's possible. There may be periods where it's in a relaxed state where it's not expanding, and then you go far enough away and you'll find another pocket, another universe where that's happening. And these are all just different universes disconnected from each other, where it should go on forever and ever and ever. It's an infinite landscape. And so it's a theory which explains everything we know, but it makes predictions that are untestable. How can we test some of these? Some of the predictions are untestable, these predictions of other universes. At least for now. But maybe we will find a way one day with a wormhole or a time machine to actually test those ideas. But it's what we teach all of our students, because it just explains everything that we have right now.
See, you were going to be the tiebreaker, because I was stuck with it. But I had thought, I don't know, I had thought that because that's the easier way to put it, okay, the Big Bang happened, this is what we know. Mm-hmm. And it seems for whatever reason, a medical, astronomy, all physics, all this, even when a lot of top-notch guys know that what they maybe have published or written or they don't want to go against the grain. Mm-hmm. And I think that's such a negative thing for advancing, so for like young people, like you were just saying, how many young people want to get into this? I hope when they do, if technology shows something else, they're not afraid to go back and say, well, maybe we were wrong about this because we can't quite figure it out.
Yeah. I love those ideas. And actually, on a very, very simple calculation, the last paper I just submitted 2 weeks ago was kind of like that. I won't go into the details of it too much because it's a really boring, dry calculation, but it was essentially a formula that everybody in my field had assumed was true for 3 decades, since the birth of my field of looking for planets beyond the solar system, exoplanets. And everybody was using this formula, and nobody has ever questioned it. It's just something that your professor taught you, and then their professor taught them, and it just gets
go
passed
along
down.
with it.
Yeah, and so I think it's really important to sometimes step back in science and just question skeptically, where do these things that we think we know really come from, and work it through for yourself. And maybe if you work through it, you'll come to the same answer, and then you'll have a deeper understanding, you'll agree with it, and you'll feel confident teaching it. Or in my case, you might walk through it and realize it's actually totally wrong.
Yeah.
And everybody's been assuming this because they were just, too lazy to actually figure it out properly for the first time. And they actually see a profound insight that can actually advance science. So certainly that's the beauty of science, is that it's not dogmatic. At least it shouldn't be dogmatic. It inherently, it's not. That's what distinguishes it from religion. It's allowed to question itself. You don't get hung at the stake for questioning, at least you shouldn't do.
Yeah.
That's a core principle of science, and it's constantly in revision. And that can be a frustration sometimes to folks because they are looking for truth. They're looking for that objective, true, almost like a religion. They want that to understand the nature of the universe and who they are and their place in it. And science can't really offer you objective truth. It can only offer you what we know so far. And you have to just go in knowing that's always up for revision. In 5 years, we could rip that up and it could be completely different. But that's not a failure of science.
No.
It's just us learning, and that's how it works. And that's why it's actually so strong, because we're allowed and we're encouraged to question and be skeptical of what came before.
And I really think a lot of people are just afraid to do it. And believe it or not, just because I can't pronounce a few of these things, you know, I read some of your papers going against the grain, you know, and I really respect that because I watch them and I see them and I know that they know that that's wrong. Like I've read it that it was proven, but you know, maybe they're afraid of not getting funding or this or that. And that's a big deal, you know, not to go on with it. Now an exoplanet, explain what an exoplanet is. And because that was your thing, right? Exoplanets and moons and how the two connect, you know, how they go hand in hand in a sense.
Sure. So as we know, we have 8 or 9, depending on how you count it, planets in the solar system.
When I was coming out, there was still Pluto.
Yeah, depending where you sit on the Pluto thing. That's a whole other debate we can have later.
When I was growing up, everybody was like, Pluto, and it was ice, and then it wasn't, you know.
Yeah, that's always a fun discussion. People have lots of views on that.
Isn't it a planet again now?
No, it's by the International Astronomical Union, it's a dwarf planet at the moment. But
what would you say?
So
anything that says committee, union, anything like that.
It puts you off.
After Dr. Malone and all those other guys, anything that says I don't. What do you think?
I like to think of Pluto as a world. I know that's a little bit of a cop out, but I think of all the objects in our solar system as worlds, because it's like a rose beneath the name still smells as sweet. What we call it doesn't affect. Pluto doesn't give a damn what we call it. Right? It really doesn't care. And you see the images from New Horizons of these mountain ranges, of these ice glaciers, and you realize what a rich, complex world it is. You have an atmosphere, things we never knew before the probe went. And so it's hard to look at those images and not be awed by them, to be fascinated by the complex geology that's happening in those worlds. And so what we call it, to me, really doesn't matter. And I try to avoid getting into that debate. I certainly understand the arguments on both sides, but in practice, actually makes no difference. And I know some people do really care about the semantics and the nomenclature, but to me, it's just a distraction. When I spend too much CPU cycles on it, it's just a distraction from the things I really want to be solving, which are actual scientific questions. So
Not a name, basically.
Yeah, I mean, who cares about the name? Call it whatever you want, for all I care. But it's not going to change how interesting a world it is. So, we have the same thing. We talk about exoplanets, an exoplanet and a planet. I mean, again, that name difference is kind of artificial. Really, they're all planets. These are just planets which happen to not go around the sun. That's what an exoplanet is. So the planets around other stars. So whether you call it an exoplanet or a planet, I really don't care. And similarly for the moons, if those exoplanets have moons, we call those exomoons. But similarly, we use the word moons, satellites interchangeably, in my perspective. That's kind of a strange thing to get hung up on. One thing people do often get hung up on with the moon situation is, when does it become a moon versus a double planet? I get asked that question a lot. So if you took the moon and you made it the same size as the Earth, what if that had happened in its formation? I think most of us would agree that's probably a binary planet at that point. But then how small does that object get until you start calling it a moon versus a binary planet? And again, there's different definitions people propose. There's no official line on this. The International Astronomical Union has never voted as to what the definition of a binary planet versus a moon is.
It's kind of weird.
Yeah, but again, I put it in that same category that
it's a waste of CPU time.
Nature is a continuum. Nature doesn't have discrete buckets, until you get to the quantum level, at least. There's no discrete buckets. When you look at the macro universe, there's everything in all shapes and all sizes all at once. And that's just the way the universe is. And so our compulsion to categorize everything is human. It's telling us more about our psychology than it is about the universe. So I tried to get try to avoid getting too hung up on that.
Good. So exoplanet, just to make simple, it's basically a planet. We'll just say planet for the sake of whatever, you know.
Yeah.
It's a freelancer, almost like a freelance planet that just doesn't have the sun, doesn't have a star going around.
It does have a star.
It does have a
star.
star.
So there could be planets without stars as well. So
Okay,
I think by freelancer, we'd call that, usually it gets called like a free floating planet or a rogue planet, something like that.
Yeah.
So, you know, there are, we think, actually probably billions of those things wandering between the stars as well. Likely in the early solar system, there was probably another gas giant in our solar system, in between Uranus and Neptune, or maybe just outside one of them, but another planet that looked similar to Neptune, a fifth gas giant in our solar system. And the reason why we think this is quite likely is that when you simulate the solar system from, you know, the initial conditions and you simulate it forward, most of the time you end up ejecting Uranus or Neptune. So it's actually very difficult to get from the initial 8 planets and for them to all to survive for 4 billion years. They gravitationally interact with each other, and one of them eventually gets kicked out especially with interactions with Jupiter and resonances, and gets ejected from the solar system altogether. So one way to get around this is to actually put another gas giant there that we don't see today. And when you have that extra gas giant, you simulate it forward, that one gets ejected, then you end up nicely with the solar system that we see today. So whether that planet's really there or not, I think it's actually quite probable that it was. It certainly teaches us that planets are not stable. And, you know, we think of the solar system as this pristine thing that's been the same way for billions of years, but it's constantly changing. In fact, in a billion years, there's a fair chance, I think it's like a 1 or 2% probability, so maybe not super high probability, but high in a cosmic sense, of Mercury becoming unstable. And Mercury can become unstable, and then it causes Earth and Mars to switch positions, Earth and Venus to switch positions. So Earth moves closer into the sun, Venus moves further out, and obviously that would be pretty diabolical. And in fact, you end up with often Mercury getting ejected or something in this situation. So the solar system is intrinsically chaotic. Whenever you have more than 3 bodies, or 3 bodies or more, it's always chaotic at some level. And it's just a question of when does that chaos win over? Is it going to be, you know, a week, a month, a billion years, 10 billion years? In the solar system, it's of order of 10 billion years. In the early solar system, it was probably much faster time than that, maybe a few million years, and that's why we ended up with an ejection. But even the solar system today is not stable forever, and we will eventually lose probably more planets.
Or the sun will burn out.
That will happen too.
That's a guarantee, right?
Yeah, and when the sun does go through its giant phase, it loses a lot of mass. And when it's losing mass, of course, what holds the planets in orbit of the sun is its mass, its gravity.
Right.
So that actually causes the solar system to move outwards. So all of the planets will move into wider orbits. And what that means is that you get dangerously close to Jupiter, to the outer gas giants. And so now Jupiter can have some fun and start kicking things out. The dynamics is chaotic and a lot of fun. We can't predict, it's kind of like the weather. You can't predict the weather with any accuracy like a week or 2 weeks ahead. And similarly for the solar system, it's very difficult for us to make accurate predictions, like a butterfly effect. You change, one planet by a millimeter over to the left and to the right, and you get a completely different outcome. So we just don't know the positions of the planets at that level of precision that we can reliably predict what's going to happen.
You brought up weather, and it just caught my attention. You said, do you think we can control, or someone has any control of the weather? I know it's a crazy statement, but do you think there's any way out there that weather can be controlled at this point in our lives?
Certainly, I'm not aware of any technology we have that could achieve that, but we certainly think it's part of the continuum of behaviors that we might expect for an advanced civilization. So there's an idea called the Kardashev scale that Nikolai Kardashev proposed, a Russian astrophysicist. And he has these scales, 1, 2, and 3, he calls them. And a level 1 Kardashev civilization is one that is capable of completely controlling everything on their planet, essentially. So they harvest as much energy as the irradiation that hits it. So the Earth receives about a kilowatt per meter squared of solar radiation. You add that up, you end up with something like 10 to the 17 watts or something crazy that's hitting the Earth. And so it's a civilization that's using all of that energy all at once. And with that energy, they're able to control everything about their planet. They could even change the continental distribution. They could control earthquakes. They can control the weather. And so, if you have that amount of energy and that amount of resources, you would expect they would be capable of making their planet more hospitable. And if you keep going down this scale, you get to Kardashev 2s, you're not only then, this is one controlling the entire solar system and the star as well. And so now you can have civilizations which are not only engineering their planet, which we are to some degree already doing, but not the weather system really, but also engineering the star as well. And that's actually something we've touched on a little bit in my team, with this idea of making the sun potentially last longer. How can you make the sun
right.
live
kind of
forever?
An important thing.
Yeah.
And then isn't 3 where basically you can go anywhere at any time in the universe like that? Like you're basically roamers of the universe with no issue. Isn't that where the third step is?
I'd say that's maybe 4. 3 is the galaxy.
Oh, 3 is the galaxy.
Yeah, so 3 is where you're using the same amount of resources as basically the entire galaxy. 4, Kardashev never wrote about a 4, but people have extrapolated it to a 4 to be that it would be presumably the entire universe. But then what do you mean by universe? Do you mean the infinite universe? Probably
then you
not.
start to ask that question.
Yeah,
even with the quantum computer times a million.
Right. So how can anyone control infinity? It seems almost an oxymoron. But presumably Hubble volume could be potentially doable, but then you would need something that was faster than light to do that. Of course, you'd have to have either wormholes or an Alcubierre drive, something that would allow you to traverse the galaxy and the universe beyond the limitations of the speed of light. If you're stuck with the speed of light, I think anything beyond a galaxy is not really tenable.
Yeah. If there is other creatures out there, species, they're not playing with speed of light. That's like horse and buggy stuff, right?
Maybe not. I mean, we again, this is one of those points where we have to be careful. We just don't know whether we have all these ideas about whether faster than light travel could be possible, but it does lead to some problematic inferences. I mean, one problem is if faster than light travel really exists, it makes the Fermi paradox. The Fermi paradox is a statement that Enrico Fermi famously said: "How come we don't see anyone? How come we don't see the star system next to us that's been completely engineered?
Right.
Why don't we see a galaxy?
They
that's
have to be able
engineered?
to bend time, right?
Yeah. So
that's the only way.
So if a civilization has the capability to spread across not just the galaxy, not just its local stellar region, but even the entire universe, because it has this fast light travel, it makes this Fermi paradox exacerbated. Yeah. It makes it harder for us to explain. Because at least if everyone's moving slow, it's easier for us to explain it. But the faster and faster they can move, the harder and harder it gets for us to explain why we don't see galactic spanning empires, which you'd think would be a fairly obvious signature. But what's profound is that everything about, in an astronomical sense, when you look out, you look at galaxies, look at stars, and we've surveyed stars and galaxies looking for these specific artificial signatures, we've never seen one. The universe, as far as we can tell, appears to be completely consistent with being natural. And that either means that there's, maybe no one ever gets to that point of stellar engineering, of galactic engineering, or, another idea is, this kind of you probably heard Arthur C. Clarke say, any technology that's sufficiently advanced is indistinguishable from magic. Yeah. And another take on that is that any technology sufficiently advanced is indistinguishable from nature.
Sure. Nature, yeah.
Maybe the galaxies we see, we think they're natural. They seem natural to us, but that's just because everything we've learned is actually the product of their engineering. So that gets very fanciful at that point, but it's certainly something that it's a credible hypothesis, but it's just very, very difficult to test such a hypothesis.
You have such a cool job. Yeah. A very mind-blowing one, but such a cool job.
Right.
I don't know how you sleep. Your brain's probably constantly just like I'm sitting here listening, and I'm just like, man, my brain just keeps going.
Because you'll say one thing, and then you start thinking. Yeah. You'll say one word, and then guys like us, we're like, oh, okay, wow,
yeah, no,
maybe, what if?
It's fun. I was saying a couple of weeks ago, I was on vacation, and I was thinking about. I spent the whole week reading papers about many of these conversations we've just been having about intergalactic civilizations and their behaviors and constraints on them. And in my last outreach video I did on the Cool Worlds YouTube channel, I talked about this. I had this very profound moment where I sort of realized a solution to the Fermi paradox that no one had ever really written about. And it shook me so much that I had to spend, I think, 2 or 3 hours just walking up and down the beach. And my wife was like, where'd you go? Like, what's going on? But I had to just decompress because the idea had just startled me so much.
Yeah, it's your YouTube channel.
Yeah.
That's so cool. I love the background.
Oh, thank you. Yeah,
I do. You know, you got the spaceman over there. It's so cool.
This is very much. I mean, this is very much a low. I say low effort. We put a huge amount of effort into the channel, but I mean, my real job is being a professor at Columbia.
Yeah.
So this is like a little side,
Like
side
fun.
thing.
This is a little fun thing for
Yeah.
you. You know?
So it's nice of you to say, because I often look at it critically and think, man, we should be putting more effort into this and that.
No, who cares? I just think it's cool because you know you're a professor on that level, so you're looking at all this stuff. But for the average person, sometimes when you get too crazy with it, it may shy somebody away. But when you make it not, you know, like the banner thing you were just saying, I know what you were going to say, like this isn't, you know, giving enough justice to what we're doing.
Right.
But it's like, oh, cool. You know, he's not some asshole that thinks he knows everything. You know what I mean?
Yeah. I think having the connection to research and being a professor, I mean, it's probably true. It's almost certainly true. I could earn a lot more money doing that full time than I could being a professor. And I've never seriously thought about doing that because I love research so much. I'd never, A, wanted to be taken away from it. But B, I think the channel is enriched by the fact my fingers and my toes are in research every day. And so I'm not regurgitating what others have written. I'm in the field, I'm thinking about it, I'm working on writing papers. And so I always felt it was nice because you're removing the middleman. You know, why, if you want to buy something, you don't want to work through a middleman, you want to go straight to the source. You want to hear from the engineer about how that car works. And so I always loved the idea of giving people a direct tap, a direct route to how science is actually working. So that was the philosophy and why I started the channel.
I love that you just said that. We're from Philly and raised a lot different than this stuff is now.
Yeah.
And when you said, like, you know, I could do this and make a lot of money, but who cares about it? I mean, you got to have money to live, and it's nice. Yeah. But if it's not your love, okay, you'd make a bunch of videos, and then what? You know, you don't have these extremely intelligent people to speak with and learn new things and pop up new things. That's really respectable.
Yeah. I mean, we only make a video once every 3 or 4 weeks. And everyone in the channel is like, oh, wait, make more, like do this every week. But that'd be, because it takes us a week to edit the video. So then it would just be, that's it. You know, I just all the time be scripting, filming. It'd be full time. And I enjoy that process. I enjoy sharing. And I certainly have no shortage of things I could publish every week.
Scroll down.
But I think it's super crucial to keep one foot in the world of research.
Yeah, I mean, and so you speak very simple. You know, you don't make it all complicated and with big words. That you just make it understandable. Okay. I should say.
Thank you. Yeah.
And being that, I want to go back to moons because I think this is really interesting. When I talk to people about the moon, they don't. Maybe I'm wrong, but if the moon wasn't here, we wouldn't be sitting here right now. Is that correct?
It's quite possible that's true. There's several reasons. Again, we can't do the experiment. We can't take away the moon to prove it. So I can never. It's very, very difficult for me to prove that to you. Absolutely.
Or the ocean. You know, it has a lot to do controlling with the ocean, the weather, and so on. When I tell somebody,
so some of the things
you wouldn't believe this. So they're like, what?
Yeah, this is actually all comes back to an idea called the rare earth hypothesis. The idea that the moon, especially, could play a very influential role in the habitability of our planet. So it all comes back to there's several layers here, but the earliest one is just the formation of the moon itself. So the formation of the moon was thought to be, there was a Mars-sized planet called Theia, it's usually the name we give it, that was essentially wandering, possibly trapped in a one-to-one resonance with the Earth, and it kind of wandered too close to the Earth. The Earth would have been larger initially, so it would have actually been a super Earth back then, and there was a collision, a very dramatic collision. And that collision essentially vaporized the majority of that Theia object, and debris from the Earth was kicked off, and that coalesced and formed the moon. The reason why we think that's true is just because when you look at the isotope ratios of the Apollo moon rocks that we have, thanks to the Apollo program, it's identical to that of the Earth. And we don't see that for any of the planets in the solar system. So it really does look like the Earth and the moon formed from the same stuff. And that's very difficult to explain without an impact. Now, that impact may have been already crucial to kicking things off in the right direction for life. It probably, the super Earth, we think, the more mass you have, if the Earth was more massive, it would have had a thicker crust, lithosphere. And the thicker the crust is, the harder it is to have plate tectonics, right? Because the plates get heavier and heavier, and eventually you run the risk of what we call a stagnant lid, where essentially it's kind of what Venus has. And so without that, if you just have a stagnant lid, which would have been possible without the impact, you lose the carbon cycle. The carbon cycle is crucial to life. So this is the way that, when life, like imagine something living in the ocean dies, like a whale or something, it sinks down to the bottom and its body decays there, and there's lots of other organisms, of course, and the seabed's just covered with this. And that carbon gets trapped. All the carbon in its body is just now stuck on the bottom of the ocean. And if that just happened forever, then eventually all the carbon would essentially run out. All the resources for life on the surface would be gone. So the carbon that sits there gets recycled, and that's the carbon cycle. When an oceanic plate subducts under a continental plate, because of plate tectonics, that plate melts, and so the whale body, all of that carbon that sat on the bottom, goes back into the magma, and then will eventually come back out through volcanism. And so there's a natural cycle of the Earth keeping care of us, looking after us.
So I was like 2% right.
Yeah, so that already is interesting. And then on top of that, after you form this big moon, our moon is unusually large compared to other moons. In a relative sense, it's 1% the mass of the Earth. No other moon in the solar system is that big, except for Pluto, which is 10%. But then, do you call Pluto?
Interesting, right?
So back to the Pluto thing. So the large moon, the fact we have a large moon means, and it's kind of crazy, when the moon first formed, it would have been much, much closer in our sky. It would have been about 100 times larger when you looked at it in our sky. It would have been kind of crazy to see. And it's so large at that point and so close to us, it would have been driving huge tides on the ocean. And so those tides would have washed over entire continents. Yeah. Not just a few, a couple hundred meters or so, but entire continents. And so now you've covered, entire land masses with rock pools. And so those rock pools may very well have been the seat for the origin of life. And now you're basically multiplying the chances by millions by having those large tides. And on top of that, a third reason is that the obliquity of the Earth, so we have an axial tilt of about 23 degrees. That's what gives us our seasons. And that 23 degrees number seems to be locked in place by the moon. So if you take away the moon, as Jacques Lascar, a physicist, simulated this, and you just do the kind of stuff we were doing earlier, like, simulating the chaos of the solar system, Jupiter, even though it's far away from us, can influence the axial tilt of the Earth, and it knocks it over on its side, and the Earth just goes back and forth, back and forth. So you end up with regions where the North Pole is basically pointing right at the sun. Oh. And so you have half the planet. You know what it's like in the Arctic, you have 6-month summers, right?
Yeah.
But now you have that, but like a 6-month Saharan summer on the planet, right? So it's just brutal. And you could even end up with the night side even freezing out and having atmospheric collapse. So you could even lose your atmosphere at this point. So this could be a pretty, obviously, disastrous consequence. Maybe life could still cling on in some form in those cases, but we wouldn't be here. There'd be no agriculture. You couldn't have farming and things like this in this kind of climate. And it's all because of the moon that we don't have a situation like that. It's thought for Mars, its axial tilt does wander over millions of years because of the influence of Jupiter. It doesn't have a large moon.
Oh, it does.
Like we have. So that may have actually been part of the story as to why Mars is not as hospitable as the Earth is.
Yeah, whenever I say it's simple because I don't like to get into it, because it's just amazing that they don't teach this in school. Yeah, just on the simple fact, like the moon has a lot of control with the ocean. Yeah. And if you don't have the ocean right, the whole place would be underwater possibly, right? Kill animals, things can't evolve, nothing to eat. And they don't teach that we know they don't do it now, but even before. And it's just so crazy to me that that's overlooked because the moon's such a cool thing, not just a thing to look up at. It's so important. Right.
I think the way we teach, astronomy and physics, we really don't teach astronomy at schools. We teach physics, but I remember, I was a nerd, right? I loved physics at school, but even I found those classes challenging from a entertainment perspective, let's say. Sometimes they're very dry and you're just regurgitating equations and you don't really know what you're doing. You're just solving problems and there's no sense as to what it's all about. Astronomy, as we've shown with the Cool Worlds channel, it's a way of bringing people in, and maybe they end up becoming an amateur astronomer or even a professional astronomer, but it might even just be the start of their journey towards other scientific fields at that point. So astronomy is a fascinating way of opening the door for people. And so I'd love to see it taught at an earlier age to get people excited. My son, he's only 5 years old, just had his 5th birthday 2 weeks ago. Every time I come home, he asks me about like white holes,
Yeah.
wormholes, or when will the Earth die, and like the crazy questions like could the universe collapse tomorrow. He just has his mind's constantly asking those questions, and kids just naturally curious about that. And
I have a 2.5-year-old daughter, and when you walk in my house, one of the presents he got me was an alien mirror.
Okay.
So my daughter wakes up every day and she goes over and says, "Hi, alien. Hi, alien." I have to pick her up. I want to touch his eye, and she put like a alien and spaceship sticker on my shower that sticks there. And every single day, Daddy's a spaceship, that, likes the other stuff, but always says hi to the alien when she leaves. Bye, alien, right? And that's a 2.5.
Yeah, that's amazing.
And a girl,
Yeah.
So they're so interested in it, but yet they don't put any time into.
Yeah, I mean, we think of astrobiology, astrophysics as these like very advanced subjects, but we can talk about it. You can talk about it on cool boards. You can talk about it to my kids. It's something which, if you teach it the right way, is very accessible and incredibly fascinating. Can be the real start of a journey. So it gets held up in this ivory tower mindset that it's something super advanced, and I'm sort of averse to that. I think we should try to integrate it all the way down, because it can be the beginning of a real journey for people.
Don't laugh at me when I ask you this, but do you think we went to the moon, or do you think that maybe we didn't go to the moon?
Yeah, it's interesting. There's a lot of skeptics about that. I'm convinced we did. One of the clearest pieces of evidence for me is the laser ranging experiments. So there are mirrors that are put on the moon by the Apollo astronauts, and we bounce lasers off them on a regular basis, and we use that to measure the distance to the moon.
Could a satellite have put that up there, though? Or a rocket or something else would put that up there? Because it was like a race to get up there. And I know that guy was a film guy, Siegel, or I forget his name, Siegel or whatever. He's like a conspiracy guy. But it was slightly compelling. It was like, oh, wow, well, I could see how this could maybe be possible. But you think we were there? This episode is brought to you by Fiji. More than just water.
This is not just rock. It's ancient volcanic rock that filters tropical rain, giving it double the electrolytes and its signature soft, smooth taste. It's not just water, it's Fiji water.
This episode is brought to you by Let's Get Checked. Are you the man your father was? Recent studies have shown that men's testosterone levels have dropped substantially since the 1980s at about an average of 1% per year. Think about how old your father was when he was born. For example, if he was 30, your testosterone levels could be 30% lower than his. Low testosterone levels can have all types of health effects on men. It can affect your mood, sex drive, memory, muscle mass loss, you name it. And yes, low testosterone is more common the older you get, but it can affect men at any age. So let's talk about today's sponsor, Let's Get Checked. You can order a testing kit that will be delivered to you in a discreet packaging with next-day delivery. Once your sample arrives in the laboratory, confidential results will be available from your secure online account within 2 to 5 days. So, if you want to test your hormone levels without having to leave your home, visit trylgc.com/MSCS MEDIA and get 25% off your test using the code MSCS MEDIA. The link is in the description at the top.
It's not an area that I've studied extensively, but
you got bigger stuff. I was just curious.
I think everything I've ever encountered about the video evidence, the footprints. We've even imaged the Apollo landers on the surface, from recent missions that are orbiting around the moon. You can see the trails of the rover tracks they drove on the moon. So I don't see any. I personally have never encountered any reason to be like, that doesn't make sense to me, and there must be another explanation. As I said, this laser ranging experiment. We talked about tides earlier. That's how we know the influence of the moon's tides on the Earth, because it's moving away from us about an inch per year. We're measuring that from lasers bouncing off that thing, and that actually means the Earth is slightly slowing down its spin because it's losing angular momentum if this thing's gaining angular momentum. So the actual Earth's day is slowing down as a result of that. So that experiment is one that I've come across and encountered the most in my work. And it's clearly linked to the activities and one of the missions of the Apollo program. You can see the astronauts laying this thing down in video. So yeah, I've not seen any reason to be skeptical about it.
Why do you think we haven't been back there since? And NASA kind of just went like under a pillow for a while with, you know, and then SpaceX popped up and everything. Why do you think we haven't been back to the moon? Like walked on the moon again? Why they put funding just elsewhere and didn't care, or what do you think?
It's not profitable.
Because it's not profitable.
There's no money in it.
No.
Right. That's what it all comes down to in life, isn't it? It comes down to money. There's no way at the moment that we could really imagine making any economy from the moon. The only thing that really comes to mind is tourism, but there's just there's very few people with either with both the money and the will to do that, right? And there seems to be an anti-correlation. Like usually when you get very wealthy, you become a little bit more protective of your life. You're less likely to want to take those risks. There are exceptions to that for sure, but apart from tourism, there really hasn't been much of a motivation. It's a difficult world to live on. There's very little water. There is some water, but not like on Mars where you have polar ice caps, which you can actually just see when you look at a photo of Mars. You can see a north and south pole covered in ice, just like the Earth. So huge amounts of water. There's even been liquid water flowing on the surface of Mars that we've seen from high-rise images. So we know there's plenty of water on Mars. Mars would make sense to me as a place to try and build a base. The moon, we kind of need to build a base there, but only as a step towards Mars. There's nothing
to take off from the moon to Mars, right?
Yeah.
See, now, like, say I had $10 trillion. I would want to invest even though I'm losing money now, I would want to invest because how if you find something on the moon that you didn't, that could heal something, even though Big Pharma would buy it up, still you could sell it to the assholes.
Yeah.
But if you got to Mars better, just what you could find out there, even as an investor, I mean, you just couldn't imagine. But they just thought, well, right now there's no money, so
right. It's a huge investment. So I guess we need someone to have that vision. But one of the things I would most want to do as an experiment on the moon would be actually coming back to the idea of looking for life in the universe. It seems a strange place to look for life in the universe on the moon, but I think it's a place where we might find relics, artifacts. If the Earth is 4.5 billion years old, that's a long time, even on a cosmic scale. And so they're very, our civilization has lasted for 100,000 years, depending how you count it. Our species for a million years at most, depending how you count that. So that's nothing. So there could have very well been many, many civilizations in our galaxy. And again, you can get from one side of the galaxy to the other in about 300 million years, even with our chemical rocket systems. So it's possible if you were very patient, if you had like a AI robot that just sat on that thing and waited, it's quite possible to get across the galaxy. And that's nothing compared to the age of our planet, 4.5 billion years. It's still a tenth of that. So it's quite possible that our Earth would have, I think, stood out for a long time. We're looking for habitable planets. That's my job. And if we found a planet like Earth, we'd be very, very interested in it because it would have all the hallmarks of being a planet that would go on to form a civilization. And surely another civilization out there would recognize that if they saw the Earth. They would see the Earth with something special and that it would be worthwhile attempting to send missions there. We're even talking about doing that now to an Earth-like planet around Proxima Centauri b. So if they had that impetus, what do? If they find, and I kind of have this suspicion that they are the only ones in the galaxy at that time. They've looked around, they don't see any neighbors, they seem to be the only ones. But that doesn't mean they're going to be the only ones forever. There could be someone in the future that arrives, such as us. And they may wish to communicate with them, not through space, but through time, a time capsule. And that's not optimum. They would prefer to have a dialogue, but that's just not possible because we're not here yet. So their only option is to have this conversation through time. And so they have to leave us something to find, to have that conversation, a time capsule. The moon is the best place in the solar system to do that. It has no weather system, it has no plate tectonics, it's completely inert. The imprints of Neil Armstrong's boots are still there now and will be there for millions of years. So anything you put there, it's the safest place you could possibly put something, especially if you bury it. If you put it under a meter of the lunar regolith, that's there until the sun dies.
Once these quantum computers get out, you'll have every criminal in the world going to the moon and hiding money up like on the moon. It will still be there,
Perfect place to hide something. So I've always said this is such an obvious thing to do that we should be scanning under the surface and looking for metallic objects that we can find. I don't know what the chance of that success is, but it's a fascinating experiment, and there could be a horde of information under our fingertips that we've just never actually endeavored to look for. So, I mean, that's from a SETI perspective, the Search for Extraterrestrial Intelligence, SETI, that's one of the things I most would like to do as an experiment.
Now, this is like such a cliche thing now, but all these things that we're seeing supposedly that are UFOs, extraterrestrial, blah, 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 do you really think that they are? Or do you think that the government has them to instill fear? You know, what's your thoughts? And then what's your thoughts? And then factually, what do you think? You know, because that's two different things.
Yeah.
Obviously.
I think it's a big topic that the science community are wrestling with. For years and years, UFOs were the giggle factor, right? And so we just laughed it off and we said, that's just stupid, we shouldn't talk about it. It's the same category as like Bigfoot or fairies and
like some guy with a tin hat on was in his farmland and saw something, and you know, tinfoil guy, you know.
You know, these kind of sexual experiments being conducted on people, it's that kind of stuff. And for a long time, that was laughed at by the science community. I think we are starting to realize, as our search for life in the universe has broadened, we used to just be looking for radio signals, and that was it. And then it has recently evolved to be a bit broader than that. And so now we're looking for planets which have had climate change on them, because that could be a sign for extraterrestrial intelligence. We're looking for planets that can have satellite systems around them. We're looking maybe on the moon for these technologies we just talked about. And so the concept, the cloud of things we're looking for is constantly expanding. And so then you get to the point where you say, well, if we consider an interstellar probe that's flying through the solar system, like Oumuamua that Avi Loeb, I'm sure, talked to you about when he was on the podcast, if we consider that a possible signature of alien intelligence, what if it goes into the atmosphere? Does it stop at that point? Because that's weird. Like, if you consider it science when it's outside the atmosphere, but then not science when it comes into the atmosphere, that's just inconsistent. So we have to at least admit that it is just as a broad as, it belongs just as much within the field of technosignatures as any other thing that we might do. And if we laugh at it and we giggle at it, it risks the thing the whole alien hunting has struggled with for decades, which is, the government and has laughed at it. Congress has laughed at it and removed all the funding. That happened in like the early 90s. A Republican congressman stood up and said, this is a complete waste of money looking for aliens. And so the whole program got killed. And so that giggle factor it's always a risk with looking for life. And so we have to at least admit that it's a reasonable thing to attempt to address this question scientifically. So that's my pretext. Sorry for the pretext, but
no, I love it. I love it.
So in terms of what we've actually seen, I mean, I have to say, when I saw the Navy, the Pentagon videos, I was like, wow, that's very interesting. Like, what? Right. My initial reaction was similar to that reaction on the beach of like, what the hell is this? This is pretty, because before that we hadn't had anything that was anywhere near that compelling, right? We'd seen blurry photos and things, but this was actually video evidence, and it was coming from such a reputable source. That was the big difference, right? It was coming from pilots, it was coming from the military, that it seemed much more believable. So for me, that was immediately very interesting. One of the folks I follow is Mick West, and if you've encountered him, but he's kind of a UFO skeptic, and he's gone into his garage and has been able to reproduce with infrared cameras many of the effects that have been seen with these videos. So, for instance, the gimbal one can be largely explained with a rotating camera and just the reset of the orientation of the camera.
Like, simple terms, like a hologram.
Yeah, or like an illusion.
An illusion.
Yeah, an optical illusion almost. And so there's actually a mundane explanation. It's the jet of an airplane, but it's just the cameras rotating to create this effect that looks like a weirdly rotating thing.
But then when you see that one that goes from, all of a sudden, boom, down into the ocean, or just clicks.
Yeah, so I don't record his explanations for all of them off the top of my head, but he goes through the 3 videos and he presented pretty, to me, reasonable alternatives. They're all a little bit contrived. They all require, some kind of like very peculiar set of circumstances to come together. But then you're comparing that highly unusual set of natural circumstances with the possibility that it's aliens or some kind of, advanced spacecraft. And so that's where your priors come in. And I can't tell you or anyone else what your priors should be. We use this term priors in statistics. It really means your prior belief about the likelihood of these two things being true. If your prior belief is that it's a very, very plausible and likely thing that aliens would visit us, would be monitoring us, then you would probably give much more credence to that idea. If your prior is that this is a really unlikely thing aliens would do, they would probably contact us first, or they would have a much better way of cloaking themselves. Why would they have this kind of cloak that sometimes works and sometimes doesn't work, and even our simple technology can detect it? Then maybe you'd put much more credence to the alternative hypotheses. So I think that's where we're kind of stuck, and it really depends on your prior belief. But certainly I believe there are alternative, if what somewhat contrived, explanations to many of these things that we've seen. And so that's why we want more data, of course. It's hard because obviously there's many accounts. The parts accounts are some of the most compelling things I've heard. But on the other hand, human memory, even from a trained observer, is difficult to weigh that evidence scientifically. What do you do? It's almost like a legal proceeding at that point rather than actually a reproducible experiment. So that makes it very difficult. What I want to see is, and I think Avi Loeb's trying to do this, is to get high definition video.
Definitely can't say that word. Remember, I screwed that word up too. The big one he's working on. He's going to kill me when he comes in. And he's coming in, I think, next one. The what?
The Galileo project.
Yeah, You think I would be able to say that?
Yeah, it's a bit of a mouthful.
Yeah.
Well, Galileo Galilei is even more of a mouthful. That's the guy's name.
Well, I was trying to say it perfectly for him, you know?
Yeah, and I think that's a good. I mean, if he could provide evidence like that, or maybe new videos surface from the Pentagon or something. But at the moment, it's what's frustrating as a scientist is that the UFO phenomenon is not new. It's existed for many, many decades, and always the evidence is at either level of a complete obvious fraud, or it's at the level of a grainy photo. Always. It's never a super high resolution, crisp video, which is kind of wild because camera technology has grown massively in that time. So we've had this huge increase in our imaging capabilities, but no meaningful increase in the credibility of any of the evidence that we've collected. That worries me.
But then payoffs come in if the government doesn't want anybody to know. It could be the government that are shooting these things up there. Maybe they did get one from a while. I'm just throwing things at you to see what you think.
It could be a conspiracy theory. I tend to be a little bit conspiracy theory skeptical, just because having, I've worked for NASA and I've seen there was a huge amount of disorganization, and these people are, they're brilliant scientists, lots of brilliant people there, but everyone knows who's worked in government that it's also a complete mess, and there's lots of disorganization.
You don't need to be a rocket scientist to know that one, right?
And the leaks. I mean, there's been so many leaks from, we just had one a couple of weeks ago, right? There's so many government leaks happening. Why isn't there leaks of that level of volume of information that we've had? So for those reasons, I remain interested, but skeptical a little bit. I think a lot about the story of Percival Lowell when I think about UFOs. So Percival Lowell was a famous industrialist in 150 years ago or so, and he got really interested into astronomy, and especially the idea of life in the universe. And he became convinced that Mars had life on it. And he just thought, Mars has ice caps, as we've talked about. He looked at it through his telescope, and it looked like the Earth to him, and he just said, it must, and if there's water there must be life. How can there not be? It's a planet which is a similar size to the Earth. It's a similar distance from the sun, has water. It has life. And he wrote books about that. And then eventually he gave, because he was successful financially, he gave a huge amount of money to creating the Lowell Observatory in Arizona. And so one of the prime purposes of that telescope was to study Mars, to look for life. He was also told by an ophthalmologist in Boston that he had the greatest eyesight he had ever encountered. His eyesight was exquisite. He had remarkable vision. And when he looked, and he was loaded with both the idea that his vision was perfect and that Mars had life. And so when he looked through that telescope, his millions of dollar telescope at the time, probably an equivalent money, and he looked at Mars, he saw streaks on the surface of Mars he couldn't explain. To me, that's very similar to the UFOs in sense of it being a ambiguous, grey, fuzzy thing, not a crisp line, a fuzzy thing, because it was at the limit of the capability of the telescope. But he saw these things, and he interpreted them to be canals. And so for that made the newspapers. It was all over the front pages of, astronomer discovers Mars has canal system and intelligent life. People were speculating about this canal civilization and their technologies and what they use these canals for. And it seems laughable in hindsight, because we think, why would an advanced civilization build canals? To him, canals were the height of advanced technology at the time. Right, that was the era he lived in. And so, he injected that into what he saw. And so you have to be so careful of humans injecting what they want to be true, which he clearly did. And we wasted 30, 40 years looking at that damn planet, trying to map canal systems that were never there.
Yeah,
and it was just an optical illusion. Was it a waste? Maybe it's not a waste. Maybe it was useful for us to learn that lesson. And maybe we're going through the same lesson now with UFO. Maybe there's something interesting going on with all of these accounts. Maybe whether it's Chinese balloons or whether some phenomena that we just don't understand in the atmosphere. There's something to be learnt, so I think we should study it. I definitely understand why the Pentagon wants to study it. They want to know what's going on in their airspace. So it makes total sense to me. And I would put the possibility as aliens as a remote but interesting possibility. And so it's credible, but I'm just not convinced by the current weight of evidence. And I'm cautious because of the lessons of history.
I just had, again, I go so back and forth with it. Like, I had Stephen Greer, and he has some, you can call him conspiracy guy, but a lot of stuff he said, you could back up with facts. Maybe not all of it, but some of it. So I go back and forth, and I think, okay, well, these things, they look like UFOs, IPAs, whatever the new name is this week. But if you're let's just say that they are. Okay, and you bend time however you got here. Why would you go around a fighter jet? For what point? Like to show off? Like they would be so more advanced, right?
Yeah. Just
being able to get here, whether as an avatar or whatever you want to call it. Why would they go mess with the 757 or a fighter jet or I don't see why they would even come across that. That makes no sense to me. But then if you have the government shooting it up there to instill fear, to go along with all this other craziness, then all of a sudden, the aliens are coming, and then run to the government.
Yeah.
So to me, I go back and forth with it. But then I say, I don't think so. Because, when you talk to, because Elon had said, look, I have 10 gazillion satellites up there and I haven't seen anything, but would they allow you to see it? Would we even see it? And then, okay, so maybe there's not. But then I go, well, how do you go from a car phone? Because when I was growing up, when somebody had a car phone, that was the coolest thing in the world.
Yeah. You wanted to ride with that kid.
Yeah. I wanted to be in Franco's car. Yeah, and in no time, boom, you got the iPhone, this, that, the other. Like, that's a lot of technology fast. And then you got Bob Lazar, who never, said, all he said was, look, I was taken to S4 or whatever, and I was working on this. And people kind of took him out of context. He just said there's nothing on Earth that is like this that is known of. So as far as you're concerned, we don't have any, you would say factually that we don't have any craft, and what we're seeing most likely isn't extraterrestrial.
That's my belief, but I can't prove it, because, one of the challenges with the alien hypothesis in general is it's basically not falsifiable. If you let's say you see a UFO on Monday, Tuesday, Wednesday, and so you say, well, it might happen on Thursday, and then you don't see it, I might say, well, that means I'm dubious of your hypothesis. But then you might say, well, he was just doing something different that day. He knew you were going to come or something. There's always a way out, and that's the problem. It has infinite ability to evade detection capabilities if it is so advanced. Whenever we don't see something, you can always explain it. And similarly, whenever you see something you don't understand, aliens come to the rescue. So those are two very peculiar properties of any scientific hypothesis. It can explain anything, even the universe itself could be explained by aliens to some degree, right? You can explain anything with aliens, even why this water's so cold. You know, you could say, well, that was because aliens chilled it before this meeting.
Right.
And I can't disprove that, but it seems contrived to me that would be the explanation. And then on the other hand, you have the fact that it can, no matter how advanced my telescope becomes, because I've observed many times from the telescope and I've never seen a UFO. I've looked at the stars, and then I observe as an amateur astronomer regularly.
I'm just jealous of the stuff you can see through that thing.
Right, but then I've never seen anything. But then someone would say, well, you've just not seen anything because, you were unlucky, or you just weren't looking the right day or something. So it's unfalsifiable, and that's another big problem with it. So as far as I can tell, I've never encountered any compelling evidence, and I've looked at the stars a lot and looked at the sky a lot. And that's not for a lack of hoping it to be true.
Yeah, we all hope.
I think people assume we have some agenda. There's so much distrust in our society. I'm sure there's people in there who think he has some agenda, he's hiding something. There's no agenda. We just want to find the truth, and I really I'd love there to be life out there in the universe. It's been my life mission since a child to look for that.
I read all of it, yeah.
And I'm just trying to be clear-headed, level-headed, sober in the analysis of the data. The more I want something to be true, the more I have to push back about the probability of being true. If I see something that's irrefutable, if you show me an artifact from an alien spacecraft, there's so many spacecraft, why don't we have any artifacts that we can study, and like we could buy one on eBay because there's so many of them lying around and you could look at them. But this is clearly more advanced technology.
But then you would get the comeback, or the devil's advocate would be, well, if they did have them, they wouldn't show you. They would have it at area 17, I know there's 51, whatever.
Yeah.
Why would you get to see it? Say they only have one craft. Okay, well, they're not going to give it to you. They're going to build it to
That's fine.
themselves.
That's fine. Maybe I'm not seeing it, but I'm not going to be convinced in the absence of that. That's all I can control. I can't control whether they show me X, Y, or Z, but I can control my belief. And I'm not going to believe something just because, Tom, Dick, or Harry says that they've saw something. I need to see the evidence and have my colleagues be able to reproduce the experiments and be able to test this thing and actually poke at it and look at it. And that's just not happened in an open forum. So I'm going to remain skeptical about that until that happens. But that doesn't mean I'm ruling it out. I mean, being skeptical doesn't mean it's impossible. It just means I'm awaiting you to present me with evidence that is irrefutable. And to my opinion, that evidence has not been presented yet.
One more thing, and I'll get off the UFO thing, I promise.
Yeah,
okay.
It's fun.
Right.
Yeah.
So, I was watching that documentary, the one with the crash in Brazil. I don't know if you've seen that one.
No.
It just don't waste your time. He wanted to come in. It's just I don't think so. I mean, that's a compelling one, but then you have Stephen Greer, who I respect, really nice guy, had a lot of info. I don't know what you think about some of the things he says. But then again, when I go back in my head, if there was this many crashes, right? You have supposedly one in Brazil, here, nobody has not one piece of anything. I mean, you have whistleblowers coming out from Google, risking their lives while getting killed. Right. Whenever somebody comes in and they don't open a bottle of water, meaning we go, oh, they tried to kill you, huh?
Yeah.
And within an hour and a half, 2 hours of the podcast, we're like, no, they tried to kill me. Yeah. So we've had 7 or 8 people in here.
Wow.
They were like, you're okay.
I'm worried about the water now.
No.
The aliens are actually behind the curtain. We have an alien that chills the water.
I wish. Hey,
we can't show it to you, though.
What did I sign up for here?
But, Professor, you're right. There's not one piece. Nothing. So as much as we all want to so bad, there's nothing.
Yeah.
There's no evidence physically.
But it's broader than that. As I said, it's not just what we're doing, not just the study of UFOs, but the search for life and alien life is much broader than that. As an astronomer, I can tell you, it's the search for, as we said, engineered stars, spacecraft that were traveling through the solar system, the search for artifacts in the solar system, and radio signals.
They haven't been here, huh?
Whatever we just have a long series of no, no's.
Yeah.
And that doesn't mean they're not there. There's always ways out.
But
as
you
we
think,
said.
but you think at your best guess. I'm sorry to kill you with this,
Yep.
but you think that those things we're seeing are not extraterrestrial, and we don't have pieces of a UFO as of right now. You do not think that based on facts and in your mind.
I'm skeptical of that.
Okay, good.
Yeah.
Okay, now I can let that go.
Yeah,
Promise.
but I could be convinced. I think that's important. I'm not dogmatic. I could be convinced.
That's awesome.
Yeah.
And that's what makes you a great professor.
Yeah.
And
How much
not that you
tougher?
need that from me.
How much tougher do you think it's going to be now? We talk about the big thing everybody talks about right now is AI, and all the capabilities and where we're moving to. And Tommy talks about the quantum computer and all that type of stuff. Where right now it's hard for people to disseminate between facts or reality and what's real and not real. Right? It's so hard sometimes. That's real. No, it's not. That was edited that way or whatever like that. But how much harder do you think it's going to be as AI keeps progressing that you really will not know the difference between real and not real?
Yeah.
Is that a concern?
It's hugely concerning. The potential for disinformation has never been higher. The current era we're living in, it's only going to get worse. We actually experimented with Cool Worlds of making. I wanted to do the videos in other languages. So there's this thing called Synthesia.
Can you pull up Task Force's website? Your website now, the front page of your website's cool. If you're into space, well, I mean, I put it on the main screen. Yeah.
So we grabbed this. There's a company called Synthesia.io, I think they're called, and they will create a virtual avatar of you. So we actually tried this out. I haven't put it on the channel, but I wanted to make videos in Spanish and Hindi, whatever. And you stand on a green screen and you do like a training video, and then the AI learns you and can create a digital duplication of you.
Yeah.
And you can speak any language you want. You just type in where you want, it translates it for you, and it speaks it with perfect, cadence, perfect accent. And it was very convincing. In the end, I sort of felt a little bit creeped out by it, so I didn't go ahead with it. But with deep fakes, and you couple deep fake technology to the capability of ChatGPT to just generate such convincing answers that they essentially pass this Turing test of you can't tell if you're talking to a person or a machine, and its ability to spawn endless amounts, right? A human can only make so much fake content. There's only so many hours in the day. But a machine.
And then you got Bill Gates that bought it.
so there's a really dangerous potential there, and I don't know how it's going to try. As a scientist, it's something we're thinking about. I mean, should ChatGPT be allowed to write scientific papers? We don't really know how to handle that. Is an AI allowed to write a paper, do research, publish it? Or does it require a human to always lead these efforts? And these are conversations we have to figure out. How do we review? Eventually, these super intelligences are going to exceed our intelligence. And then how do we review what it's saying? Like how can I evaluate whether it's right or wrong if its IQ is like 1,000?
You're going to go to Elon and say, hey, you know that neural chip that it's not ready yet, just give it to me now, right?
Right. So there's lots of problems, and I'm as concerned as anybody else about the new world, especially as a father. So you feel the same way. As we used to always believe, study hard at school, and like languages. I've always told my kids, I don't know if there's that much point in learning languages anymore, because the Google Translate for years has been able to translate everything perfectly. And now coding, we used to teach our kids coding, but now again, ChatGPT can code anything. So you just say what program you want to write. You're a coder and this, and it can write code that's equivalent or even better than what most of us can write.
Yeah, I don't have to hit the backspace. I don't have to hit the late, because in code one symbol you're pretty messed up.
Yeah, one little typo. And should we be teaching our kids coding anymore? And then you go further, you like math, physics, and eventually we'll just all be these clueless, dumb apes that are just completely dependent on these machines.
I really think that's what they want. I think they're just waiting for that. The quantum computer this is just my belief, and based on guys with higher IQs than me, like you, I think that they're just waiting on that quantum computer. And I don't think that's much bigger than what I've seen. And I think once that is ready, then I think, real quick, I just think real quick, it just becomes where you just slowly, basically become extinct unless you're of that hierarchy almost, because I think that will, offer, if you want to have sex, you put your thing in a thing and here comes whatever girl you've ever dreamed of. Yeah. It looks like her, feels like her, everything,
We're just pets at that point.
Yeah. Population's down. We're not having as many kids. I mean, all the signs are there. And then as more as you go toward government control, then one day they say, okay, now digital currency. Here's money. Here's a paycheck. Here's this. Oh, and here's your new goggles where you can go anywhere you want.
But do you think we had this conversation the other day? Did you think that we were? How do I say this? We were already at this point in the past, meaning we've had this crazy AI or this technology we call it now, and back then, you talked about there's underwater cities, there's these fucking crazy pyramids. Like, did we have an crazy advanced civilization then that maybe we really don't fully know about, and then something happened, and then we kind of like not started over, but started over, and now we're built back to where we were?
Yeah, I'm not an archaeologist, but most of my colleagues who work in that field obviously are pretty skeptical there was technology at the similar level to what we have now. They don't see evidence of that when you dig inside the pyramids or anything, unless, again, you put your conspiracy theory hat on and say, well, it's been hidden. But it is scientifically plausible there was a very advanced civilization on our planet, let's say 50 million years ago. Mm-hmm. You go back that far, there's basically they could have had cities like New York and there'd be no sign of it in the geological record. Or at a level that is so small, it's quite unlikely we'd be able to recover it. People tend to think that, like we've got dinosaur bones, so we have a pretty good sense as to what was going on back then. But a tiny, tiny, tiny fraction of all dinosaurs that ever lived ended up in museums. So the vast majority of their bones just decayed and we have no sign of them. And that was only because dinosaurs literally, in the very wide variety of species, completely dominated the planet for that time. If there were advanced civilizations, it is quite possible that we've lost evidence of them in the past, and that's called the Cerulean hypothesis that actually one of my colleagues in New York, Gavin Schmidt, proposed. One thing we can probably say about them, they probably didn't go to the moon, because when we served with one of the projects in my classes, we actually looked through lunar imaging data. And you look through that data, it has sort of 10-meter resolution. I wish it was a bit better than that, but that's kind of the level we have, at least publicly. 10-meter resolution. You don't see any of the artifacts on the moon that would be at that scale. There's no cities, there's no other landers, there's no spacecraft, except for the stuff that we put there. So it seems like if there was a previous civilization, it never left any signature of itself in space for us to find. No satellites. We don't find any artificial satellites or lunar relics or anywhere else in the solar system. So that's possible, though, that there was a civilization that got to the point of AI, but they just didn't have an interest. I mean, not everyone might have an interest in space. They might just, as I said, be interested in...
Because you look at, the pyramids, and you talked about, I forget what it was, the vibrations or
from Graham Hancock.
And I don't know for sure, but, how did they perfectly create those things? Do you believe that they literally lugged all these crazy stones and built these pyramids? I guess that's just my wonder.
Yeah, I do believe that, and I think what worries me sometimes about because it was same for Easter Island, the giant heads, I can't remember the name, the Maori heads or something, but they for a long time were a puzzle, right? And we had no idea how someone could possibly, without a truck or something or a crane, possibly lift these gigantic rocks with human strength. It just seems impossible. And so for people for a long time thought, but that must be evidence of an advanced civilization, aliens or something came down and did that. But then it's sort of a decade ago, a team of anthropologists were able to move the rocks with ropes, and they kind of make them walk. So they kind of tie ropes to the head, and they get sort of 6 or 7 of them on each side of the rope, and they pull in resonance back and forth until it starts to rock. And then once it starts to rock, they just slowly walk it along the tracks. And so they were able to reproduce it and move it. But that took a lot of research to figure out that's how they did it, and a lot of ingenuity. And those people, we've spent, I don't know, 20 years trying to figure that out. But that was their life. And they spent their entire lives thinking about that, thousands of people. And it's easy to think that people back then were dumb and they didn't know what they were doing, but there were geniuses back then who figured this stuff out. And I sometimes worry when we attribute these ancient accomplishments to, well, that must be aliens, because how could someone possibly do that? It's just because we haven't figured out how they did it yet. But it's reasonable. There should be stuff they know that we don't know. Of course, there will be the Elon Musks back then as well, sure. and the Platos and Aristotle's, geniuses of their time that figured this stuff out, and maybe it just didn't get recorded how they did. That seems a much more likely explanation to me. There's always been genius people in our society, and so I think they figured it out, and I don't want to take away that accomplishment. I think it's sad to take away that accomplishment from them. That's kind of an amazing thing that they did that.
And the pyramids, in my belief, I read a lot of Graham Hancock. He's coming in, but I tend to believe him. And when you look underwater with the solar, it looks like a city to me. I'm sure you've seen that.
I haven't.
You haven't seen that?
No.
You stay up there.
Okay.
Good. Yeah. But I think, in my opinion, there was another civilization, and they just we're worried about what we wear and what we dress and space and that. I think they were just more in touch with each other, and they found a way through nature, or just a way that we don't think, to be able to build the pyramid. And even though it is within 1 degree of the North Pole, that's pretty tough to do. But I think that was, just in my opinion, I just think that was an earlier civilization that wasn't so obsessed with money and materialistic things. And if you take all the money and materialistic things and what you have and what I have away, and put your brain power in other places, think what you could do.
Yeah.
What do you think of that theory?
I think I'm totally open to the idea of there being civilizations that were lost to time. I don't know anything about this city near the underwater at North Pole, so I can't really speak to that. But my wife's an anthropologist, so I love talking about these ideas with her. I'll have to ask her opinion about that as well. But one of the things that most fascinates me in the study of previous civilizations is this period of time called the Eemian. So it's about 200,000 years ago. So right now we live in the Holocene, and the Holocene is a period, the Neolithic period, we might say, of a warmer climate than usual. If you look throughout history of the temperature swings the planet has endured over hundreds of millions of years, we're actually in a slightly warmer period than typical right now. And that's useful because if that wasn't true, if the planet was covered in much more ice, then it wouldn't be possible to do agriculture, and you probably wouldn't have had the boom. So if you look at the human species, we've been around for about 500,000 years, and we only started farming in 3 or 4 locations on Earth pretty much simultaneously across the planet: Mesopotamia, the Aztecs. We all started farming about 10,000 years ago. And that seems like, well, how could they communicate with each other? Why did they all just arbitrarily start farming 10,000 years ago? Why not 30,000 years ago, 40,000 years ago? Because there's obvious advantages to farming.
Right.
Yeah. Why would you want to go out hunt every day when you could just
why would you want to go fight a tiger, with a stick? That would just be funny. But so I guess, but kind of true.
Yeah, it was a pretty dangerous world back then. Right? So
I had some of the mushrooms around before they went that tiger boy.
It's mysterious. And so barring alien intervention or something, the most likely explanation is the climate did clearly warm up at that period. So at 10,000 years ago, the planet starts to warm up, and so that enables farming because the change in the climate. That's the most likely explanation, I think. So that makes sense. Okay, so you have this period 10,000 years ago, the planet warms up, but then you go back further back. That's the current episode. You go back 200,000 years ago. There's another episode like that where the planet warms up for about 50,000 years or so. Roughly, the number's a little bit hazy to me, about 200,000 years ago, there was a period called the Eemian where the Earth should have had, as far as we can tell, a similar-ish climate to what we enjoy today. It had humans with the same brain capacity as us. Maybe they were slightly less developed, but it's difficult to believe that they didn't have the capability that we have to just do simple farming.
Yeah.
And yet, there's no evidence for that. As far as we can tell, a civilization was not born. Maybe a civilization is lost, there were advanced civilizations that were born during that period. We just don't see evidence for them. But to me, that's like, if I could go back in time to one period and just see what happened, I would want to know what the humans were doing and whether any of them tried it or how far along it went. And it's like it's another roll of the dice. You know, we've only got this one roll of the dice we can look at. I want to see another roll of the dice, because if we didn't do it, if we just never had the idea, maybe if we had 100 tries, we'd never have the idea. And we were just incredibly lucky that we did it this time. Some genius had the idea of farming. It seems strange to think of it that way, but it speaks a lot to the probability of apes, of conscious animals going on to form intelligent technological civilizations. And that's obviously one of the numbers we want to know about life in the universe. How often do civilizations get born from intelligent beings? And there's 2 experiments, and it seems like we're 1 for 2. And that's interesting to me.
Yeah. But now, why would why would we be 1 for 2, and why is that interesting to you?
If we're 1 for 2, then that kind of implies that it's not inevitable. I think we tend to think it's inevitable once you get to a big enough brain.
I just wanted to get that out of your mouth.
Yeah,
it's not inevitable.
Yeah, that you inevitably start farming, and then the natural course from that is maybe you start building huts and houses, and cooking your food and having a civilization born from that. But the fact, if we really didn't do it for this period of time, it could be interesting. It could just be the humanity was under enormous population stress at that time. Maybe 200,000 years ago, the population was just too small. I mean, it's hypothesized, if you look at the genetic differences between people, that the population probably did go through a bottleneck, the human population at one point. Maybe as small as I've read, 600 individuals at one point were left on the Earth. And of course, if you have a population that small in small fragmented groups, it's just unlikely anybody has the time to think hard about anything, right? Because you're just clinging on for survival in every second of your life, and every moment's probably miserable and hard and brutal.
Nightmare. And like we're talking about a bad day because somebody cut you off. 200,000 years. You want to talk about a bad day? Whenever we can go back to them.
My internet's not working.
We're gonna cry about it.
Damn it! No Wi-Fi.
Meanwhile, 200,000, and you think. And with what you're saying, 200,000 years ago, just as intelligent as you and I, just only 600 people having some really bad days.
Yeah, that's one possibility that it seems to make sense that you would require a certain size of population, that you have enough opportunities to have, genius people born within that civilization, but also enough capacity to feed your group that not everybody is desperately clinging on to life, right? There's actually some free time to invent, to think, to try out new things. And so that's one possibility for why the population at that time didn't have the idea of doing what seems obvious to us, of starting to farm and starting to have a civilization. But if you threw me out into the Canadian outback and then say, why don't you start a civilization by yourself? I'm probably going to be dead in 3 days. So it's not surprising to me.
I mean, that makes total sense. I mean, if there's only 600, do you think right now you would be looking for exoplanets and moons? I mean, I think you probably would be looking for the next glass of water to stay warm or cool, or one of the two. I don't think
your priorities change.
Okay, that's cool. Back to trying to live another day. To me, that makes total sense.
When you talk about the population, right, and we talk about all the stuff we talk about nowadays, overpopulation, some people say, right? We talk about global warming and all that type of stuff. In your opinion, or your checking, is there a way that the Earth can be overpopulated, meaning that it'll destroy the Earth if we're overpopulated? Now, we may kill each other and hate each other and do all that type of stuff. And on the aspect of the global warming, like, is this just something that's naturally going to happen? And it doesn't matter if we burn gasoline all day long or do this, that has no effect on...
There's the population that drives it. I think it depends how we live. I mean, you can have 10 billion people living in the same way as Native Americans did, and it's probably going to have it would inevitably have a far less impact on the climate of our planet than 10 billion people living how a modern American lives. It's obviously we're producing far more carbon into the air than those people did. We are literally changing the chemical composition of our planetary atmosphere through these industrial activities in a scale that the planet has, as far as we can tell, has never seen before. So I think it's more of a question of how we live, not necessarily the population numbers itself. I think there are pathways to having even large populations than today, but sustainably.
But do you think, like, when you look at, everybody talks about global warming, it's always a hot topic, right? And the green energy and all this type of stuff. So we're going to mine and everybody's going to have electric cars, and that's great for the environment. Meanwhile, the batteries get thrown into the ground. And the lithium does that. But, like, I don't know the full question, but basically...
Is it bullshit?
Is it bullshit? Yeah, I guess.
You know, because we've seen, and, you know, just we were just talking about it now. It goes hot, down, hot, down.
Yeah.
You know, of course, the top, you know, they take that and, you know, got to do this, a good gazillion dollars for solar panels and that.
Like,
actually soul code.
Will we be the ones, I guess
story.
I guess what I'm trying to say is, will we be the ones that we blow the earth up, like, because of us? Or is it just something that naturally is going to happen?
I think both are true. The Earth is changing. In 1 billion years' time, way before the sun becomes a giant star, in 1 billion years' time, none of us will be here because the Earth will naturally get warmer over time. The sun is warming up over time. It's becoming more luminous. And as it becomes more luminous, it's making the Earth hotter, and that's naturally happening. And so, but that's a very slow process. That's 1 billion years. So yes, the Earth is becoming less hospitable to life in general, not just us, over time. We are, you know, kind of accelerating the changes that the planet would experience to some degree. The chemical composition of the atmosphere is always changing over time. There's been periods where the oxygen level was much higher and much lower than today. The carbon dioxide level. I mean, when the Earth was first born, the atmosphere was probably almost completely carbon dioxide. And that seems terrible to us, but that was actually a good thing back then, because otherwise it would have frozen. The greenhouse effect was enormous, and the sun was less luminous when it was first born. It was about 70% the luminosity of today. And so without that carbon dioxide, the Earth would have frozen over into an ice ball. So there are always changes happening to our planet. It's, you know, when I think about climate change, it really is an act of self-preservation. It's, if we, you know, continue to make our planet warmer and warmer, the Earth is just fine with that. It's not really about saving the Earth. The Earth will be fine. It will eventually recover and go back down to cooler temperatures again. It goes through cycles. But we're screwing ourselves over. You know, we're screwing our ability to farm. You're making parts of the Earth unarable, right? So you can't actually do agriculture in those regions. You're going to raise the prices of food. You're going to increase the sea level, so that's going to destroy coastal cities. You're going to, you know, potentially destroy interesting biospheres and diversity in our planet that our future generations can't enjoy anymore. So it's really about us when I think about climate change, is what kind of world do we want our kids to live in? I don't think climate change is an existential threat. I think we'll survive through it. Almost no matter, you know, whatever we can plausibly do to our planet, I can imagine humans surviving and persisting. We're kind of like cockroaches at that. You know, we're very difficult to eradicate.
How did they make it through everything? Cockroaches made it through everything, right?
I think in the you could nuke a city and the last thing left would be the cockroach.
Those guys, you can't kill those things. Yeah. When I was I used to read a lot about it. It's kind of weird, but I was just very interested as to, you know, they went through the Ice Age. They were still around, and if there was,
they fly in Florida.
They don't fly around. But with the climate change, correct me if I'm wrong, because I don't want to put words in your mouth. Okay, there's climate change, but it always happens. Yeah, we're adding to it, but it's not the end-all, be-all. What maybe is more of the end-all, be-all is all the crap that we're throwing in the ocean, all the crap that then goes into the soil, that goes into the food we eat, and so on and so forth. Because, you know, they make it like the climate change is like the end of the world. And in my opinion, I don't think it's doing anything. Maybe it's accelerating it a little bit, but nothing major. I mean, you know, you're the professor.
Well, I think it's hard for us. I think the danger is it's hard for us to perceive these changes because they happen on timescales which we're not used to thinking about. We tend to think about what's happening, you know, when's the next show on HBO coming next week? You know, we're interested in that kind of timescale. But these timescales happen over decades. It's there's no doubt the planet is warming up. That absolutely no question about that.
But naturally, and just a tiny bit more than usual because of us.
It's almost certain it's because of us.
Oh, really?
We have increased the CO2 content of our planet by about 25% at this point. So it should naturally be about 300 parts per million. It's
Really?
now over 400 parts per million. So that's a pretty sizable change. It's unquestionable that CO2 is a greenhouse gas. You put CO2 into a beaker, you shine light through it, and you can just, you can do it in a laboratory. It's a pretty trivial test.
Wow.
So there's no doubt that we are adding a gas into the atmosphere at a very significant level, which is warming our planet, and we are seeing a warming in the planet which correlates to that amount that we've put in. So in that sense, I'm completely convinced that our activities are increasing.
And I do believe that, but I also think too, like, everything again comes down to money and politics, right? So we're going to argue that, gasoline's bad, and you need to all go to electric, and then so now it's a battle here, and money's involved. This guy paying this guy, and this guy doing this. If you were the guy in charge of everything, just you, right here, you right now, what would be your solution then for what we consider what's being called global warming? Is it that you move every single person to electric and we mine all these lithium batteries and throw them out later? Is it completely get rid of gasoline? Is there, there's probably not an end-all be-all, but what would be the most cleanest version to do all this type of stuff? This green pathway.
Yeah. Well, fortunately I'm a scientist and not a politician, so
take politics out of it. But from a science perspective, what would be a plausible way to be more green or clean? I guess clean.
I mean, as a scientist, what we want to do is reduce the amount of CO2 that is emitted into the atmosphere. That's what it really comes down to. Now, how you achieve that is a political question. Whether you do it through particular rebates on Tesla cars or Hyundai. I drive the Hyundai 105. How you actually implement that. There's many pathways. It could be carbon capture. It could be carbon negative technologies where you actually pull carbon out of the atmosphere. It could be all going EVs. There's multiple pathways towards that, and it's really a question of a carbon tax. That's a question of economics and politics. I don't feel qualified to assert as to what the right thing to do is. All I really care about is the bottom line. It's like when you look at the budget at the end of the month, you don't really care about, you should care about how you win the money, but you really care about, I'm actually in the black, right? That's kind of the most important thing.
Right.
So as long as we're in the black and we're actually, controlling our carbon emissions and bringing it down, then I'm happy. And as long as the economy doesn't collapse in the process.
Correct.
That's two black things.
Don't forget to throw in that part.
Right? I got you, because I just find that part interesting, the global warming thing, because it's always the hot button topic. Everybody talks about it and it gets argued back and forth. And I don't think that electric cars are per se the enemy and bad, and you should have to go gas, and the gas people fight with the electric car people. And it's like, okay, well, if I don't think everyone has to move. I don't think we could do it right now with our power grid system. If every single person moved to electric, I don't think it could happen. But I think it's just good to hear that.
We did an episode on that on Cool Worlds about lithium recycling. So if you look at the amount of lithium that's required for all these batteries, and you compare it to the rebate to the mandates that the Chinese government has put, the US government, Europe, and they're talking about 2030, 2035 having 100%, 50% vehicles on the road being sold, being electric, and you calculate how much lithium that requires. It's way more than what we're mining, and the mining has gone up massively. But even if you extrapolate the current mining trends, it's above that. There's just no unless and the problem with the mining is it takes years and years of advanced planning. Of course, it's not like an immediate thing. You can't just start mining tomorrow and have the lithium process for cars. It takes years of planning ahead. So there's a big problem there. And so the solution we suggested in the video was you have to recycle the batteries. Don't throw them in the ground, like you just said. If you throw the lithium in the ground, the dead batteries, then I think we're screwed. We have to recycle these batteries and get the lithium back out of them. And it's really hard to replace lithium, of course, because it's the lightest metal. So you can use a different metal, but you can have a heavier car, and then it's less efficient. So if you want the peak performance, lithium really is the best way to go. But there's no shortage of lithium per se. It's just that we can't get it out fast enough in time with these aggressive timelines that are being politically mandated. But there's a huge opportunity, I think, for recycling these things. That's, I think, a business.
That would be huge. I think that would be a game changer, right?
Yeah. And there's companies trying it. There's companies making progress. They're kind of shredding the batteries or melting them down, but they're not doing it at scale. But there are companies starting this.
And being that you said factually, and even your theory that aliens haven't been here yet, I guess I'll throw out the window that maybe they planted us here. I always thought that first. No, I really did. I really thought I thought there was a logical thought that aliens from another planet had come and said, okay, this looks good, boom, throw it. We don't like it, boom, throw an ice age. It sounds like a stupid cartoon.
Humans or life on Earth?
Life on Earth. Like, so say, from whatever galaxy, Z planet, wherever they came. They said, okay, Earth looks good. Throw this seed here. They turned into dinosaurs. This didn't work out too well. Maybe they were maybe a little too big in the lab, Okay, throw an asteroid at them.
Yeah.
I'm joking about it, but that's kind of, I could see that possibility. And then, you whack them out, no good.
Yeah.
You put the next one in, because there's been a bunch of ice ages, we think.
Oh, right? A bunch of mass extinctions as well.
Mass extinctions.
It's been like 5 or 6 in the last 500 million years.
I'm very glad to hear you say that, because I thought that, and now I know.
5 or 6 mass extinctions?
Yeah.
On our planet Earth, you're saying?
Well, those are only the ones we know about. So this is going back to the last
the only ones we know about.
500 million years. If you go further than that back in time, we just can't tell. Yeah. But in the last 500 million years, I think there's been 5 mass extinctions. The most recent one was the one that knocked off the dinosaurs, the KT transition. And then some of them we just really have no explanation for. It's very confusing. So the earliest one is it's called the late Ordovician mass extinction event. And it's actually connected to astronomy because it's possible, we think, that a gamma ray burst, which I did a video about a couple of videos back,
YouTube channel,
could be the explanation as to what happened. So a gamma ray burst is it's a massive star that when it dies, it produces huge amounts of energy out of its poles, much brighter than even a supernova. And if you fall in the jets of these poles, I think if you go to my video, you'll see the thumbnail of the event. That one right there, the second one. That thing right there. So that's an event that's so deadly. It basically strips off the ozone off the upper atmosphere. And then once you've got no ozone, the UV comes down and it basically leads to rapid genetic mutation and destruction of DNA in life on the Earth. And it doesn't extinguish everything, but it especially on the surface, it's pretty deadly. And you see these huge dips in the number of marine genera, which is sort of the number of species on Earth. 5 dips, and one of them doesn't really have a good explanation for, but we think could be connected to it kind of lines up with the frequency you expect those kind of events. But I mean, it's also possible, you're totally right. I mean, who knows? Maybe someone threw an asteroid at us at that point.
No, that's really what I thought when I think I asked Avi the same thing, like how many times has this and I believe I'm sure he said the same 5, right?
Yeah, I think he
5.
said 4.
Yeah.
And then and then I just came to, I was like, well, maybe they planted us here and it just didn't work out the right way, and the dinosaurs, that wasn't too good, and then we just happened to be the lucky ones, and now we're just what we're doing to her. That's hold on.
It's a valid idea. It's called directed panspermia.
Oh,
that's
cool.
That's the official name.
I'm glad. Well, there you go.
Tommy, say that word. What's that word?
Directed panspermia. I'll say it one more time.
All right, hit me with it. Hit me with the professor.
Go ahead. Say the word.
Directed panspermia.
I can say that one. Directed panspermia.
Very good. All right.
Yeah. So panspermia is the idea of life, intermixing between planets. So you can have, it could be indirect is kind of like assuming it's natural. So essentially like a meteorite could strike the Earth and a little, extremophile could be clinging onto that asteroid, ride all the way to Mars and then start life going on Mars.
Yeah.
So that's kind of the idea of panspermia. It could even happen that life started first on Mars and then a bit of rock got chipped off that and actually triggered life on Earth. There's some interesting arguments that Mars could have been habitable before the Earth and have had liquid water for a period in its early history, and then maybe that's indeed where life began and moved. So maybe we're all Martians.
Do you think that?
It's
give me a percentage of what you think.
I'd say it's like a 10% probability.
That's pretty good, 10% in the world.
It's possible, but it's not my. I think usually I prefer the simplest explanation. The simplest explanation is that life just began on Earth because that's where we are. But I can't. It seems perfectly plausible that life could have started on Mars at any time. Directed panspermia is when you have aliens involved. You have someone with agency and intelligence actually throwing rocks around. The challenge with that is, for a long time, we did think that was incredibly implausible, because especially if it was happening through meteorites and things traveling through the galaxy, the travel times are so vast and space is so big. It just seemed really unlikely that you'd hit gold, right? You'd have to throw it so precisely to get it to hit the planet you wanted to hit. And even with lots of opportunities and failure rates, it just seemed unlikely you'd get that to happen. But then I think Oumuamua, this discovery of interstellar asteroid, has got people thinking about this a lot more, as Avi probably spoke to you about, because we probably have underestimated how often interstellar asteroids are moving through the galaxy. There seems to be a lot more stuff out there than we assumed. It was kind of a surprise when we discovered it. We weren't expecting the telescope to find anything, given the predictions of how often this should happen. So it seemed very surprising. So one idea is that it was obviously an artificial craft of some kind, that which Avi's quite keen on. But it's also just possible that there's just a lot more stuff out there, interstellar asteroids, than we previously assumed. And that's interesting, because then it raises the possibility of either natural panspermia or people weaponizing these things to spread life. If you did think, I'm pretty pessimistic about our civilization. It's easy to be pessimistic these days. If you believe the end is coming, and you believe that life is rare and there's hardly any of it out there, Elon Musk often talks about preserving the flame of consciousness, I think is the expression he uses. If you think that's a primary mission, then maybe you take it upon yourself to make sure that life spreads out and there is a chance for it to continue elsewhere, even after we're gone.
Mars, space travel,
Yeah, and so there's even been discussions of manufacturing solar sails, which are very thin sheets of mylar, basically aluminium, and you kind of could inject into it these little bacterial spores that would have human DNA even encoded within them, genetically engineered. And we could imagine almost being able to do this already, where we could put these things out and they would take a very long time to reach their destination, hundreds of thousands of years. But to the universe, that's nothing.
Yeah.
And maybe 99% of them get destroyed on the way by hitting interstellar dust or something.
But if that 0.5% hits right.
Yeah, if we build enough of them, some of them will eventually land and potentially seed life elsewhere. So it's not, there's no argument I can find as to why that can't happen. That seems perfectly plausible. I'm a little bit skeptical it's the origin of Earth. And I'll tell you why, and that's just because life started so quickly on the Earth. So it would make more sense to me if there was like a period of maybe 1 billion years after the Earth was born, where just nothing was going on. And so that would make sense. So an alien saw the Earth, they saw the Earth was this sterile planet, but it had the right potential. And then they were like, let's send something over. And of course, it's going to take maybe a long time for it to reach. But it seems like more or less as soon as the Earth was capable of having life, boom, life was there almost straight away.
Unless they had a really good aim. Right?
Unless they were very nearby.
Which could be possible.
Yeah, they could be very nearby. But I would be more convinced by that idea if there was a prolonged period where everything was in place, but just for some reason nothing happened. And then suddenly, out of the blue, life started. If to me, that would be a more convincing set of circumstances for a panspermia origin of life. But it seems totally consistent with the story you would expect for a natural origin, the way things appear to have played out.
When you look at space, right, and I'm not you're really into space, you're really into space.
I just can't say the words.
Yeah,
really
so I've heard about that new telescope that's capturing all these amazing images right now.
JWST.
Yes.
Yeah.
So there was one maybe about 6 months ago where apparently a planet or a star, don't quote me on this, I'm not exactly sure, went into a black hole, got sucked into the black hole, and was spit back out. Is that true?
You might be thinking of a tidal disruption event. It couldn't come back out. If something goes into a black hole, that's a
that's what I thought. That's what I thought when I read it. It said that it was spit back out.
So, you have a great video on that, by the way.
So I'm not familiar with that image, but a tidal disruption, it sounds a little bit like a tidal disruption event but maybe you can find it. But a tidal disruption event is when
the one before it. Because that's your video on
Yes.
shiny black. That's a really good video.
Thank you. Yeah, that's on tiny little black holes, which we could potentially manufacture ourselves, or even black holes that could have been born very early on in the universe.
So once you go into that black hole, I got sucked into it.
Play on that, Rob.
You're not coming back.
I'm gone. I'm done. I'm in
Well, you're gonna die. I mean, when you die is gonna depend on the size of the black hole. If it's a very, very massive black hole, this is a tiny black hole. If you fell into a tiny black hole, you're probably dead way before you even reach the event horizon because of these tidal forces. If it's a very, very massive black hole,
I know that's a tiny one. It's just easy to understand and to, you know.
Yeah, these are beautiful. This is two
amazing.
black holes merging together,
and that's real, right?
Space-time. Well, that's an artist's recreation, but the data is real in terms of we've observed black holes.
So what's on the other side, I guess, is my question then.
I mean,
do we know?
On the other side is eventually there's a singularity. So some people argue about whether the singularity truly exists or not. It's almost, I guess what's hard about what's inside a black hole is it's almost non-scientific to ask it because we can never take observations from what's inside the black hole by definition. But eventually, as you fell in, you would once you cross the event horizon, you'd sort of lose your ability to see the universe outside of you. It would sort of shrink into a narrower and narrower cone as you pass through. You'd also see the universe essentially speed up in terms of the time distortion. So from from the outside, you would seem to slow down. Whereas for your perspective, the universe would seem to speed up.
Yeah.
So you'd get a huge time displacement. And then as you fell in, you
do such a great job on these, really.
Oh, cool. Thank you. You would feel your feet being pulled down faster than your head. And so it'd stretch and stretch and stretch you, and that's called spaghettification. And so it would rip you apart into a stream of atoms that would just, like a column of atoms falling into the singularity. What happens when you hit the singularity? I mean, and that exact mechanism is really difficult to. I mean, again, some people will even argue whether there is truly a singularity. If you have a Kerr black hole, which is a spinning black hole, it doesn't even have a point singularity. It has a ring, and so there's a huge amount of speculation and hypothesizing about what happens if you fall through the ring, because there is no point. So in principle, something could survive if it was strong enough to resist the tidal forces. If the black hole was big enough. And so then, as you fall through the ring, is that the beginning of forming it through a wormhole or something? And people have ideas about connecting these black holes to form those sorts of things. So there might be pathways of having safe travel through connected black holes, which is essentially a wormhole. But certainly for a singular black hole, you're not. I'm gone. You're not coming back.
I'm gone.
Yeah, because like when I was in high school and they still talked about it, a black hole, I don't know if maybe we just had come out with them or talked about them more. A black hole would suck you in and crush you. Then that turned into, a black hole could be a pathway to another universe. It sucks you in. Say you had a ship that could handle it or some way of handling that velocity and everything else. It would suck you in and then shoot you out the other side to a whole nother universe. And then there's a black hole in that universe, and that would shoot you out to another and another and another. Where are we at now? Are we back to the point where basically it will crush you and kill you, and maybe singularity, this, that, the other? Like, where do we stand now factually?
Yeah, the idea of a wormhole is fascinating, but it requires some exotic physics, and I think that's where we're stuck. So it requires basically something with negative energy or negative mass. Now, we don't know of anything in the universe that really has that property. There's some experiments that kind of reproduce that effect called the Casimiri effect, where if you put two plates very, very close together, they actually exist a slight repulsion, which is kind of like an effect of negative energy. But we have no way of sort of bottling that up and dumping it into the mouth of a black hole to basically hold open the mouth. That's kind of the problem with these black holes, that you can safely travel through them. So in the absence of negative energy, it seems... maybe it's an engineering problem, depending on how you think about it. Maybe eventually we'll discover a way of doing that. But wormholes are somewhat problematic. Some scientists think, like Stephen Hawking, who's obviously very famous for his work on black holes.
I watched him a lot. What an amazing guy.
Yeah, incredible man.
Not to interrupt you.
Yeah.
What an amazing guy,
Truly.
in that situation and still have that drive.
Truly,
Wow.
a giant of the field as well. And he has he kind of has a conjecture which pours a lot of cold water in the idea of wormholes, I'm afraid, and that is this chronology protection conjecture, CPC. And his basic idea is that reverse time travel, backwards time travel, is not possible. It should not be possible. It's a conjecture. He can't prove it, but the reason he thinks that is basically because it produces paradoxes. It produces illogical situations for the universe. Like, you can go back and kill your granddad, then you don't exist anymore. So then you didn't go back and kill your granddad, so then your granddad lives. So you get this kind of cyclic problem where how does the universe figure out what to do?
Right.
So Hawking was so bothered by these, and many physicists are, that he said, you know what, it just can't be possible. There can't be backwards time travel. Otherwise, our entire understanding of physics doesn't make any sense.
We'd be living Back to the Future number 4, 5, 6, 7, 8, 9, 10, where he's got to go get Marty, and Marty, you got to come back. But really, right?
Yeah.
I mean,
so
that's
he
a
said,
simple way of saying it.
Right. So if he believes that's to be true, and it is just a conjecture, but I think it's it comes from obviously a brilliant mind, and I think a lot of physicists agree with it, then wormholes are in trouble. Because if you have a wormhole, you always have the potential for a time machine. It doesn't have to be a time machine, but you can always turn it into one. So if I created one in the lab right now in this room, I had 2 miles of a wormhole, we could take this one and we could move it, let's say, to Jupiter. Jupiter has a more intense gravitational field, so on its surface, time actually ticks slower on the surface of Jupiter than it does on Earth. So wait long enough and they'll displace from each other in time. And so, or you could put one in a ship and just accelerate very fast, and then you also get a time dilation that way. So it's pretty easy to make clocks be out of sync with each other. And so now you could bring it back and have a time machine. Go back and kill your granddad, cause these kind of problems. So Hawking thought it was impossible. Another problem is that if you have wormholes that are close to each other, you get kind of feedbacks. Like a particle can go through the mouth, come back in the past, and then go back into the mouth again and keep looping round. And you can end up with this situation where the same particle is present in the same space over and over and over again. So you have like infinite copies of that particle.
Yeah, right.
And then you start having infinite gravitational mass and infinite energy in one place. And then again, sort of nothing really makes sense from a physics perspective. You have like a positive, it's like putting a microphone too close to an amplifier. You get a positive feedback that just almost immediately gets like loud squeaks. And the same thing would happen with 2 wormhole mouths put together. You get a very loud energy mass situation happening all at once.
So extremely unlikely.
So either that process immediately destabilizes the wormholes, like as soon as you do it, there's always a destabilization because of that feedback effect. Or there's just something, that negative energy or the construction of a wormhole itself that is just forbidden in a way that we don't quite understand yet. So I wish it was true, because again, isn't it the dream just to step off from Earth and just step onto another planet and have a vacation there?
Absolutely.
Yeah.
But maybe the physics, like right now, the physics can't show it. But maybe in 100 years, or when these quantum computers, if they don't kill us,
Correct. Yeah.
because they could do things that are unbelievable once they're ready, right?
It's
going to give a lot of answers.
It's not completely excluded, put it that way.
Yeah.
But there's reasons why many of us are doubtful that it's possible, but not excluded. So there is still hope.
But for I've read it. For someone like you to say extremely unlikely, that means it's probably really unlikely. Well, because I've seen you change, your mind many times, and you're not afraid to, But when something's extremely unlikely, you haven't been too wrong on the extremely unlikely thing.
Look, I'm never going to use the word impossible. I certainly put that because I don't want a young person listening to this to be like, well, there's no point thinking about that.
Yeah, because they might study it
because they might figure it out.
Years and figure it out.
Right. So as far as I can just only tell you truthfully, as far as I'm aware, it appears viable, but there needs to be some things that we currently don't know if it's even possible how to do need to come into place, like negative energy and some way of solving these kind of time travel conundrums, which seem to break the universe. But if there are ways around those problems, which maybe someone smarter than me one day will figure out, then I would be the first one to jump through.
Now, was it true that telescope, again, I don't know the name of the one you said.
JWST.
Recently, like maybe 2 days ago, they captured an image of was it a star eating a planet? Is that the way I'm describing it right? A star?
Oh, okay, yeah. I think I know. Yeah, so there was a planet being engulfed by a star.
Yeah.
Yeah.
How does that happen?
So there's a couple of processes happening. I mean, the planets are basically spiraling in over time. So that's, I think, what's happening in this case. But the Earth will also likely be engulfed by the sun one day in a different process of the sun expanding. So either the sun gets bigger or your orbit gets smaller. It has to be one of those two things. Planets do slowly spiral in over time because of tidal effects. The same thing we've heard a few times about. The star, as the planet gets very close, it's pulling gravitationally on the near side of the planet stronger than the back side, and that tries to basically stop the planet from spinning and even orbiting. It's trying to like hold it into place, and it removes what we call angular momentum, motion from the planet, and gradually that ebbs away and pulls the planet in closer and closer and closer. So this only happens the Earth is so far away from the sun that the tidal force is far too weak for this to really be in play. But it is happening for the Earth-Moon system. So the Earth-Moon system, it's kind of the opposite case. The moon is moving away from us. But if the Earth was spinning slower than the moon was, so the Earth's day is 24 hours, so we spin faster than the moon's orbit of 27 days. If the Earth was orbiting, let's say, once every 60 days, that was its spin period, then the moon would do the opposite and it would come in and would eventually collide with us through that same process. So
it says, sorry, I couldn't find it on here to pull up, but I saw it on my phone. It says, for the first time, astrophysicists have caught a star eating a planet.
Yeah.
That's interesting.
It's very cool. It's very cool what we can see out there, and it's going to happen to us one day. So it's kind of like seeing into the future.
Yeah, it's like
our fate.
Yeah, when I saw that, I was just like, wow.
Yeah.
And when you're searching for moons and exoplanets or planets, whatever we want to call them, what is a predictor for life? That maybe there is life, there was life there, and also, isn't it possible, just like we evolve, just like animals evolve, just like anything adapts to certain situations, just because we breathe oxygen, isn't it possible that there could be life just intelligent as us that may be on a planet that just has an atmosphere and gravity, I suppose, and the right proton? It has to have the right proton, right? Otherwise, it would just go all over the place.
The right chemical elements, maybe.
Yeah. Proton, yeah. Isn't it possible that it could be, they could drink lava, right, and that would be their water? You know, I mean, I know that's extreme. I'm just making a point.
Yeah.
And they would breathe, fumes or whatever. Isn't it possible that is possible to have life like that on another planet that's just as intelligent or more intelligent than us? Or that's just absolutely not possible?
No, absolutely. I agree with you. I mean, this is the danger of being anthropocentric.
Yeah.
Of looking at us and saying, well, this is how life happened on Earth. This is how we arrived. This is therefore the only way which it can happen. And that's just BS. I mean, we have no idea that's true. There could be completely different. I mean, that's kind of one of my problems with this idea I mentioned earlier of the rare Earth hypothesis, which says, you have to have a big moon to have the obligatory. And that's I totally understand the argument. We've talked about it already. And then not only that, you have to have constants with just the right continental distribution. You have to have just the right amount of this and that. And you can just add it all up and say, well, yeah, all of those things were necessary to get to us. But if you change the story, how do we know there's not a parallel track that leads to something that's equally interesting but completely alien to us? So I'm totally open to that idea. There are obviously some physical limitations there. So, the idea of you need some kind of chemical substrate for life to be taking place in. So it's probably want at least matter and chemical systems to be happening. You almost certainly need a source of energy, where that energy is coming from volcanism or from light. You can interchange, but you certainly want some source of energy. And you probably want some kind of liquid solvent that could move material around a body, get nutrients to different parts of an organism. But that nutrient, that solvent for us is water, but it doesn't necessarily have to be water. There are good reasons why water is probably one of the very best ones, if not the best one. but it's not necessarily the only one that life could work with.
But like you said, we're looking for life that looks and does just what we do.
Yeah.
And then a lot rule out anything else. But I just, because I there's many animals that have changed over time that, say they didn't eat meat, then they had to eat meat. Our insects all the way down the line.
Yeah.
They had to adapt. So to me, I don't see why, it has to look like us, be like us, drink water, this, that, the other. So when you're looking up there, do you put all that into perspective when you're searching for the exoplanets and the moons? And then
we try to. It's hard. So I'd just say two things. One is it's hard to look for anything, right? So you could say, well, life could be anything. Well, then how do we look for anything? I mean, then everything's alive. Like you could say, well, this cup could be alive. Right? Great. I mean, I can't prove that. I can't disprove that. So then you're just kind of stuck in this frustrating position where you haven't really learned anything. So the idea of looking for life like us is useful because we know exactly what to look for in that case, and we know the signature, and if we see that, we can be fairly confident that there's something living there. But that doesn't mean because we don't see it, there's not life there. I think that's your point. There could be other exotic forms. So it's almost like a practical, pragmatic approach to look for life like us. It's not excluding that possibility. It's just, what is the quickest way for us to get that success? What's the quickest way to make money? Like, we're not saying there aren't other ways of starting a startup or a company or something, but this is probably the most interesting way to hedge our bets right now. That's sort of the economics of the science.
Good point too. Like we haven't searched enough to rule out, okay, there's nothing else like us, so now let's go look for lava drinking.
Right. That'd be a strange place to start. It's possible,
right?
But then when we think we have made steps towards your question now more directly. So you said, well, oxygen is something we look for, but who knows if life really needs oxygen? And indeed, that's not true, because on the Earth for 2.5 billion years there was no oxygen, and life was quite happy with no oxygen. It doesn't require oxygen. In fact, when oxygen first came onto the scene, it was a poison to most life. It was actually kind of a problem.
It didn't whack out a bunch of
it probably caused a mass extinction back then as well when oxidation happened. So oxygen is definitely not a requirement. So generally what we're trying to look for is not just oxygen, but what we call a chemical disequilibrium. So it's chemicals that shouldn't be in the atmosphere without life making them. And oxygen is an example of that. If everything on Earth died tomorrow, we all went extinct, in about 1 million, 2 million years, all the oxygen would be gone because it oxidizes. Oxygen is a very reactive molecule. And so it's going to oxidize everything and it'll be gone. The fact it's still here is only because of life. And so that's the kind of signature you want. You want something that just is a chemical that's so reactive, so disequilibrium with its conditions, that it just shouldn't be there unless someone is making it. And so that has broadly become what we're looking for.
That's so cool.
And so that gives us the ability to look for all types of life in that sense.
That's such a cool job, cool, man.
Yeah.
So have you seen anything that looks probable in the Milky Way? I've always had this gut feeling that there's something in that Milky Way we just can't see with all the dust and the particles that may have life. And when I'm talking life, I know, like, something little could be great. I'm talking about intelligent life. You think have you seen anything in the Milky Way, let's say, that gives predictable hope that there might be something there?
Yeah, I think the most interesting thing I've encountered is probably events similar to, but most famously, the WOW signal. The WOW signal was a radio signal detected in 1977. There's actually several of these now that have been found. And they are radio signals being clearly, as far as we can tell, emitted from beyond not just the Earth, but beyond the satellite system of the Earth. These do not appear to be satellite broadcasts, because if a satellite orbits the Earth very quickly, so the transmission's moving, and so you can see that movement. They actually don't persist in your little telescope beam very long because they move so quickly. So this is the WOW signal happened in 1977. It was discovered by the Big Ear radio telescope in Ohio State at the time, Ohio State University, and it's a signal with no explanation, but it was a very narrow band signal, which means, as far as we can tell, the only thing that makes that is a radio transmitter. We don't know of anything in nature which makes narrowband radio transmissions yet. It was coming from deep space. And on top of that, it occurred at exactly the frequency that we expected an alien transmission to come at. So there's a special frequency called the water hole or the water line. It's at 1420 megahertz. And it's basically the frequency where the universe is naturally quietest. And so if you were going to try and talk to somebody, this would be everyone would agree this is the frequency that you want to use. And it also happens to correspond to the to a special atomic transition that presumably other aliens would know about. And so we picked up this signal right at this point, but it only happened once in 1977, and we looked over and over and over again,
right,
and never ever happened again. And so a lot of people gave up on it. I wrote a paper with there was a amateur astronomer, Robert Gray, who unfortunately passed away last year, and we wrote a paper. It was his final paper with me.
Sorry to hear that.
Yeah, and he was really a hero for the WOW signal. He spent his whole life. He built an observatory in his backyard studying this thing, so cool. And he wrote several papers. He was the only amateur astronomer, I think, who's ever used the VLA, the Very Large Array. So he used these giant 20, 30 meter radio telescopes, and he's just a normal guy. He just got obsessed with it. And
Professor Kepler, you would think that would be more mainstream. Like there would be 100 documentaries about that. Like, but I don't care if it's one or not. That's one real thing that we know.
Yeah, the signal is so high in power that there's no chance it's a statistical fluke. It definitely picked up some kind of signal. And now we wrote this final paper together where we said, everybody's given up on this because they never saw it again. Let's assume it's a beacon that just kind of randomly goes off. And so we kind of use some mathematics to model that. And we're able to show in the paper that as extensively as we've looked to try and rule out a second bleep, we haven't looked long enough. And there's still a chance, I think it was like a 5% chance that it could still be repeating. And we just are missing it right now because we're not spending enough time looking at it. So it's a slim chance, but an interesting chance.
But it happened once.
Yeah. So I think we should continue to monitor it.
Absolutely.
And there's a couple of other signals like that have been picked up in the last few years.
Why don't they ever talk about it?
I know, that's what I'm saying. I never heard any of this.
Yeah. I think because most scientists want 2, 3, 4. They want to see it repeat. Reproducibility before we get too excited. It's getting harder. I guess the problem with in 1977, there weren't that many satellites in orbit. Today, there's a lot of satellites. Starlink's putting a ton of stuff up there. And so, space is very, very crowded. And so if you see, and they're going in all different types of orbits now. The orbits used to always be very low Earth orbit, just around the Earth, very close. Now you have orbits that almost whip around the moon. They're so wide. They're really going on these very slow, long orbits. And so it's much easier now to get fake outs, to get a false alarm.
Right.
So if you see a radio signal now, I think people are like, well, I definitely want to see several before I believe it. But in 1977, there was hardly anything up there, apart from maybe a few military satellites. But none of them should have been, this frequency is protected, so none really, that's the military being cheeky, no one's supposed to use this frequency for communication. It's supposed to be protected. It's a dumb frequency for the military to use because it's the frequency that astronomers monitor the most. So it'd be really weird if the military was using it, knowing that all of astronomy is listening in on it. But that was the frequency it was picked up on. And we still are, it's just a big question mark as to what caused that. So that, to me, that's one of the most tantalizing signals. Yeah.
So when you've looked up there, what have you seen? Like, have you seen planet? I'm just going to call them planets. I don't know why I have to call them exoplanets. Why don't they just call them planets?
Let's do it.
Have you seen planets that are very likely to have intelligent life on?
I don't know if we can judge whether they're likely to have intelligent life in them. We could probably judge to some degree whether they're suitable for life in general.
So as far as we can say now are they suitable because is that because we can't see in enough? We don't have the technology? Is that why? We can only say suitable?
Yeah. Even JWST, the super powerful telescope, does not have the capability of detecting oxygen on an Earth-like planet. Even our $10 billion telescope can't do that. It's going to require something more sophisticated.
Would a quantum computer be able to get that thing to detect it?
I don't think a quantum computer is going to I mean, really, all you care about is collecting photons. That's so you're collecting light. So you want a big light bucket. So your ability to compute really has no bearing really on the capability of the telescope. You just want a giant. Yeah, we all hope, but you just basically want to put a huge dish into space. You want to get above the Earth's atmosphere where you don't get contaminated by what the Earth's doing and turbulence and stuff. And you want to collect as many photons as you possibly can, as much light as you possibly can. JWST is 6.5 meters in aperture, and it had to fold up. That this kind of origami thing had to fold up into the Ares 4 rocket that took it up, the fuselage. They couldn't make it really much bigger because there was no rocket that could lift it. But one thing that's exciting with Starship and obviously the SLS system that NASA are building is that it has much larger volume and lift capacity. So you could actually put JWST unfolded into Starship if it works. And that would reduce the cost of JWST massively. So it cost us $10 billion because we had to spend a lot of time figuring out how to fold it, how to integrate those systems. If we can just put in a vanilla mirror, we could even actually it could lift so much mass. Usually when we design these mirrors, we make them very, very light because, when it comes to launching stuff into space, mass is everything. Mass, you want to make it super light because there's only so much lift capacity. But, Starship can lift, I think, over 100 tons, right? They're talking about. So if it can do that,
I saw them do the test the other day.
You could just lift you could just literally take some of the biggest telescopes on the ground, which are not optimized for space at all, just put them up. There's no real reason why you couldn't. You have to repurpose them a little bit, but it would massively reduce the cost. So you could imagine building something akin to JWST for a fraction of the cost and even larger. And so it's very exciting that we're getting to the point where I think Starship's going to enable us finally, with obviously some beloved telescope engineering as well, but to bring down the cost and make it possible that we could actually complete this mission of
right up your alley, right? I bet you can't wait.
So we're excited about that. But for the moment, all we really know, the kind of the state of the art in exoplanets is we are looking for planets which are Earth-sized and at the right distance from their star that they would have liquid water if they had water. If they had water, they're at the right temperature that it would be in a liquid state, not frozen, not gaseous. And we've been trying to count those planets. There was a mission which I worked on really closely with called Kepler, NASA Kepler mission that launched, I think, 2007 and died about 2012. And that mission, its primary mission was to count up how many Earths are there at this distance. We call this number E to Earth, the fraction of stars with Earth-like planets, especially sun-like stars like our sun. And unfortunately, it failed. It didn't detect a single Earth-like planet. And it's not because they're not out there. It's because they designed that telescope to the very minimum level. They cut the cost as much as they could. To be honest. So it was just barely able to detect an Earth. But everything had to be going its way. If any one thing went wrong, it wouldn't work. And that's what happened. One thing went wrong. It turned out that stars themselves are noisier than we expected. And so, we looked at the sun and we said, okay, the sun's a sun-like star, so the sun's probably typical. Let's watch how much it kind of vibrates and pulsates, and we'll use that as our benchmark for how noisy stars are. We'd never had a telescope capable of seeing those noises before until Kepler launched, but then we took Sun as our model. We launched Kepler. We built it just big enough that it could detect Earth in that kind of noise case. Turned out stars were too noisy. The sun is unusually quiet, it turns out. And it meant that Kepler wasn't able to find them. And so it found lots and lots of Earth-sized planets at the right distance for life around other types of stars. There's one of the most common type of star in the universe is an M dwarf, a red dwarf star. And so we know of lots of Earth-sized planets at the right distance potentially for life around those. But for sun-like stars, we don't know of any. But that's not because they're not out there, just because we haven't had the technology to find them yet. But we have new missions coming up, like Plato from the Europeans is a mission that will do this. And we're planning our next generation after JWST to solve this problem. But, just to ground us a little bit, we are some ways off life, right? We don't have a telescope yet that could detect life. And we don't even know how common Earths are at the right distance for life yet. That's still a number we don't know. So as much progress as we've made,
we still can't look and see and tell if it's right.
There's a long journey ahead of us still.
if you had to write a paper, which I'm sure you have, but say you had to write another paper right now on your hypothesis of, is there an Earth-like planet in the Milky Way? And if not, what would be the closest Earth-like planet, in your opinion, that you've seen through fuzziness, I guess you could say, or dust?
I'm guessing it's something around a 1% level of sun-like stars, something like that. I think that's probably lowballing it a little bit. When you take the data from Kepler, has no Earths, but you can kind of extrapolate the data, and you can say, well, if I take these trends and extrapolate them, what do you get? And some folks end up with numbers of order of sort of half of them have Earths, and other folks get numbers of like 0.1%. And there's a huge range depending on how you do that extrapolation. And so I'd probably sit around the sort of the best studies, I think, end up with numbers around sort of a percentage level. But it's a little bit of a leap of faith to believe these extrapolations. There could be something that radically changes in the patterns of architectures of systems when you get close to the Earth. But my guess is there are it's a low number, but it's 100 billion stars.
Right.
That's still plenty of Earth-like planets, millions and millions of Earth-like planets in the galaxy. The real question that we want to know is how, the question you asked is a really good one. How close is the nearest one? Now, I'm not interested in that for travel perspective, because that'd be great, but that just seems like it's never going to happen in my lifetime. I'm interested in that from a telescope building perspective.
Yeah.
If I want to point a telescope and look at that Earth and detect signs of life on it, I need to know how far away it is.
Right.
The further away it is, the bigger the telescope I need. So we need to know now, and unfortunately we don't have the number because we're trying to build the next generation telescopes to do this, and we still don't know how big the telescope should be.
But really?
No, we're still stuck with that. So I would say in this decision, let's over-engineer it.
Yeah, right.
Because before we've made the mistake of under-engineering it, of like cutting it like, well, if it's optimistic, if it's 50%, then we can get away with an 8-meter mirror. And I don't want to be stuck in the position where, actually, turns out we wasted $20 billion on something that just wasn't. If we'd only made it 9 meters, it would have been okay.
Just spend the $30 million
just
or $30 billion this time. Over-engineer it by at least 25%.
Do the
right?
most we can.
Yeah.
That's what I'd like to see. And Starship really does give us the opportunity to build something really ambitious in that sense.
So what are you thinking? Are you thinking are we the only ones, do you think, at the end of the day?
I think as a scientist, the right answer to that is I don't know. Scientists are reverse. I don't know, but I like saying I don't know, and I think that's a great question.
I think it's great that you say you don't know, because who the hell knows until you could really look up there or go up there and launch for the moon.
Yeah.
How can anybody say yes or no? Right? You can say I think.
Correct.
Okay.
And furthermore, I think remaining forcefully agnostic, and I'm going to just keep being agnostic with you on this question.
Sure.
I think it's really important for as a scientist to maintain this view, because I don't want to prejudge the answer. If I say to you publicly, I'm sure there's aliens on the next planet along, it biases you, because now you know what it's like. If you come out and say, well, I'm a Republican, now you feel like you have to stand by the party on everything.
Yeah.
Right.
Yeah.
And that we get tribalized. We get pushed into these camps.
Yeah.
And once you declare a position at some unconscious level, it always affects your ability to be objective. So I try to forcibly remain independent.
That's good.
Objective, agnostic on this question. I'm awaiting the evidence. I'm going to collect the evidence, and I'm going to look at it with a clear head, open mind to both possibilities. And I'm not going to decide what the answer is until I've collected that data.
It's really good. Now I know why you breeze through Harvard and everything else, because and especially people watching, because if they're looking up there, I know there's something up there, and then they see a guy like you say, "Well, I don't think so." That could really shy somebody away.
Well, I just say if you're so convinced there's something out there, there's no point in doing the experiment. I mean, if I'm going to tell you I'm going to do a $10 million experiment to test whether gravity works, whether this bottle drops to the table, it's not worth it. We all know that happens.
Yeah.
If you already know the answer to the experiment, what's the point in doing the experiment? The experiment is supposed to be about advancing our knowledge and solving unanswered questions. If there's an unanswered question, then you have to be admissible to the fact that both possibilities are still on the table. So it just doesn't make any sense from a scientific perspective to decide what the answer is before you do the experiment. It's curiosity-driven research. It's finding answers to questions we don't know. It's the unknown that makes it exciting.
Damn, I thought by now we could at least narrow down how many Earth-like planets that could inhabit life would be, but no.
Not around sun-like stars. Not around sun-like stars. Around the smaller stars, that's kind of a conundrum of itself. It does seem like there's a lot of Earth-like planets around those stars, in fact. So that they make up 3/4 of all stars in the universe.
Oh.
They're the most common type of star. They live for trillions of years in some cases, far longer than our sun will be. And they seem, as far as we can tell, to have no shortage of Earth-like planets around them. Or at least, I'd be careful with Earth-like. I'd just say Earth-sized planets at the right distance for liquid water. We don't know if they're truly Earth-like or not. But in that sense, there seems to be a lot of habitable real estate out there. But for sun-like stars, we still don't know. So there's a lot of interesting stuff out there, that's for sure.
So at the end of the day, are we the only ones? Your answer would just be, I don't know.
I'd say let's find out.
Let's find out.
There you go.
Yeah, there you go.
I like that.
Can you pull up Dr. Kipper's website, Professor Kepler? Yeah, take us through this because this is really cool for people to check out. So,
yeah, it's just a little page we threw together this is my research group. So I have a team of astronomers who work with me. We have 3 graduate students and several undergraduates. We work obviously on the YouTube stuff a little bit as well. But principally, if you click the research tab, you can just see some insights of some of the different things we work on. So looking for moons, obviously we've talked about.
Click on moons, Rob.
I don't know if that even clicks. Yeah, we haven't fleshed those out too much just yet. But these just give you a sample of some of the different things that we work on. That last one's kind of fun at the bottom there, astroengineering. The idea of sort of turning the Earth into a telescope, in this case, terrascope, as I call it. So a few different things in there. And yeah, if folks want to support what we do, both from the research side and from the outreach side, then one kind of cool program is people can actually donate to the team. It's like Patreon, but Columbia let us set it up so it just goes straight to the research teams. Actually, it doesn't go to my pocket. It goes into
I wish it went to your pocket.
Well, it goes into an account that I control at Columbia, but can only be used for research. That's it. So every penny that goes into this is purely research funding.
100% of
Yeah,
it.
100%.
I'd love to hear that.
Well, there is a gift tax. It's like a 5% gift tax, but otherwise everything I get is used for research for sure. And so you can become, if you scroll down, there's like a few different levels, and we just you can become a member and you get access to different perks and things as part of the members that help us out. So
that's really cool. Keep going down, Rob.
It's kind of an innovative way of doing science funding, and it's allowed us. We don't. I'm so frustrated when I write proposals these days. If you submit a proposal to NASA or to the National Science Foundation, if it's risky, it's not going to go. High risk science is almost unfundable at this point. There's just no appetite for it. If you want to look for life in the universe or the first exomoon, really push the envelope, there's no appetite for it. It's been hard. And so one unique thing this funding allows us to do is to take on really ambitious, bold ideas, and maybe 9 out of 10 of them won't pan out. But that's the nature of science. It's those 1 in 10 ambitious ideas that you have to try and fail in order to find those truly exciting things.
And go back up a little bit, Rob. And even if somebody just donates $20 a month, you get, say, 200,000 people to do it. That's a lot of money, and that can help a long way, right?
Oh yeah, that's massive.
Yeah, because sometimes I think people will they're like, oh well, I want to click the big one, but I can't. But $10 can do a lot.
Yeah, and you can do a one-time gift as well if you just want to give $10 every year. Even that's
it all helps.
Amazing. Yeah. So anything people feel like we deserve and want to advance our mission of looking for life in the universe and our communication of science.
Who the hell doesn't?
Check it out. Yeah.
I saw you got T-shirts on the YouTube too, right?
Yeah.
I just saw. You go back to the YouTube right before it, right there.
Yeah, my partner
go to home
designs the T-shirts and stuff for us.
Yeah, they're cool.
Yeah, I should have brought one on today, but I was in the airport and someone recognized me and they're like, "You're the cool worlds guy." If I wear the t-shirt, like, it always happens.
awesome,
But I was incognito. They still got me.
Those are cool.
Yeah, these are cool, man. We'll have a bunch of them on. Wow.
Yeah, so that shape there, we're talking about JWST. That's the mirror of JWST. So it actually has that design, and those images you can see in the background are the first images that JWST took.
Oh, that's cool.
Oh, wow. Can you pull that up?
So it's a real like nerdy sciencey t-shirt. This one, yeah,
Still looks cool.
yeah.
That's awesome.
That's the Carina Nebula you can see in the background.
And you can get them in all different colors.
Yeah, the light looks pretty cool.
That's neat.
Yeah,
Now, you ready for this one? Because I don't want you to miss your plane.
yeah.
What do you think happens when you die? When we die, what do you think happens? What do you think happens?
Yeah, I hate to be
Scientifically.
a Debbie Downer, but I would guess what I'm going to say. I don't think anything happens. I think that's it.
You unplug like a computer, and that's it.
Yeah, I think the end is the end, and there's no. I mean, I'm not fearful of it. I often like to tell people I've already known what it's been like to be dead. I've been dead for most of the universe's history. So what was it like? I was born in '84. So what was my existence like in 1982? Just remember that. That's what my existence will be like after I'm gone. It wasn't fearful. It wasn't scary. I wasn't even aware of an absence. So I don't think it's a problem for me. I think always the worst thing about loss and death is the tragedy for those around you who obviously have to go on in their lives with someone who they've become dependent on and as a part of their lives. But in terms of what happens to me, I think the only immortality we have is that which we leave behind with our work, with our words, with what the way you taught your children, the impact you had on the world. And so I kind of like that because it it gives me a sense of urgency in my life.
Yeah.
Everything I do, every second, every minute, it's the clock's ticking, and I'm never going to get those seconds back. Everything you do. And so if there's something you want to do in your life, just for goodness sake, just go after it, because it is on. This is it. This is the only chance. And our lives are so short compared to these scales that we've been talking about today, that it's just a brief moment you have to do something of impact.
Yeah, and unfortunately, I think a lot of people, whatever they need to do to get through, they depend on that. Like when I'm done, I do this, I do that. But this podcast is brought to you by Monster Energy. Tear into a can of the meanest energy drink on the planet. Monster Energy. It's the ideal combo of the right ingredients in the right proportion to deliver a big bad buzz that only Monster can. Monster packs a powerful punch, has a smooth, easy drinking flavor. Athletes, musicians, co-eds, road warriors, metalheads, geeks, hipsters, and bikers dig it. You will too. Monster Energy is more than just the green OG. Monster has Monster Ultra, Juice Monster, Monster Hydro, Rehab Monster, Dragon Tea, Monster Max, Muscle Monster, and many more. Buy on Amazon, buy on Walmart, or go to monsterenergy.com and believe me, you'll find a place. Unleash the beast. Monster Energy. I think I'm pretty much with you. I think just like you and Avi said, I like a computer plug is what he said when I asked him.
Yeah.
Like, when the computer dies, it's just, that's it. So why are you here?
But the universe is so interesting that there's probably
Who knows?
an infinite number. I can't exclude there's an afterlife for sure. I wouldn't exclude that. But it's not what I believe is what happens. But the universe is infinite. So there's infinite versions of you. There'll be versions of you that survive on. There's the quantum. So there's, when you get deep into it, as we start the conversation, what does it even really mean to be you and to be alive and to persist? And
We just don't know.
I think some part of you, some versions of you, probably do live on beyond your own death.
You do. Like, do you mean through? So say I say like something odd, like say like the words whack. Like I'm gonna whack over that glass. Okay, I'm Italian. So, all right. So now I die. I'm done. Now Rob, because he's been around me for a long time, he always says whack. And now is that how you mean I would live on?
Yeah, and even broader than that. in science, one of the best things you could do is write a textbook. Not for yourself, because it's a horrible thing to do, but when you write a textbook, hundreds of thousands of students will now be trained essentially by your hand, right? The way you think about science proliferates through that. And the same with the videos and the outreach and popular science books you write, the people you taught in the classroom, they all, and your colleagues, as you say, they all take parts of you. And so parts of you become distributed into society. And maybe the origin of that is gone, but the ensemble of it in some sense persists. In a very informational sense, that's true. The information and the way you thought about the world persists in that sense. But soon perhaps we'll even have the ability to have conversations with AIs trained upon those words. And really, then when does the end really happen if you can still converse with the ones that are gone?
Like a digital of yourself forever, for your grandkids and grandkids and grandkids and grandkids. Yeah. And an example now would be like Steve Jobs. People still talk about him, and you still got the iPhone coming out, even though it looks the same. I think they've kind of slowed down all the software engine.
So you could have Steve Jobs on here, but like a digital recreation of him and interview him. I'd be fascinated to hear.
I bet you would go back and talk to quite.
He's coming on next week, didn't you know?
Yeah, we have a show next week. Flying back in. And everything you've done, what's one that just sticks out to you that was really a fun thing that you found or saw, or just where you were, or a cool thing that you did that just really to you, personally, it's just an awesome thing to you. Okay, you've done a lot of stuff, man. I don't know how you narrow it down. So I guess I should just say one of the many. What's one real big one?
Yeah, that's hard. I am really proud of the innovative directions I've tried to push my research in. And one of the exciting ideas, and we're still pushing on it in my team, that was on the board that we saw earlier, was this terrascope idea. And for me, I was very proud of that work. It was the idea of turning the Earth into a telescope. You want to build a bigger and bigger telescope. The Earth bends light through refraction. The Earth's atmosphere bends light. When you look at sunset, it's actually, when it's on the horizon, it's actually already below the horizon, but light is actually following a curved path to your eyes, about half a degree below the horizon, just because of the Earth's atmosphere. So whenever you have bending of light, you can make a telescope. Right. And so I proposed that. And it's those kind of papers that I get the most joy out of, because it pushes me out of my lane. Right? It's really easy to just do that one niche thing that that you've got deep expertise in. So for me, it's like exomoons. I could just write every paper on exomoons, but I get the most intellectual thrill when I push myself to do something which I don't think I can do, and discover through that process, actually, I can do these things. And I think it's so important that we're in a, especially scientifically, everyone's becoming more and more and more specialized and niche, and we're losing that interdisciplinary connection and the bigger picture of where our work sits. And so I've been proud of my attempts, whether successful or not, of trying to fight that and encourage my students and myself to broaden one's horizons and to think, no, if I have a great idea, I should pursue it, even if my background isn't particularly in that one thing. So I think that's a good lesson for life, is to try and just because you don't have the skills now doesn't mean you can't do it. It's just another obstacle that you have to cross to get to that point.
That's a very cool thing, given all the things you've done. So, like, just, because your thing was exoplanets and moons, if you think of something else, don't solidify yourself just to A and B, because C might be, an amazing thing.
Right. A lot of astronomers, you ask an astronomer, are you a theorist or are you an observer? A theorist does math, an observer goes to the telescope. And I reject that label. Because if you're a theorist, you convince yourself, well, I can't observe, I'm a theorist. And the observer does the opposite. So I can't do math, I'm an observer. And all that does is that label just puts a mental boundary that prevents you from trying something. And so I've always rejected those labels.
Right?
Yeah, right. So you just have to You just have to resist that labeling and reach for those things you want to go for, irrespective as to the conventional. We talked about naming Pluto, all this kind of stuff. Just reject the names, reject the labels, and just go after which you want.
And last thing, what do you think? Like, you have all the other, you have China. I'm sure they're building up. They're, they hate when anything we do, they copy Russia. Do you see them making any advancements before us, or do you think we'll be able to somehow make advancements with them, which would be nice in a fairy tale, I guess?
Yeah, I mean, certainly we lost Arecibo a few years ago, the largest radio telescope in the world. And now China has supplanted that with FAST. So they have an even bigger radio telescope. So they now have the premier radio telescope in the world. And similarly, we talked about Kepler, this NASA mission, which died a few years ago. China, it's a little bit unclear exactly what their plans are, but they are planning something like that. There'll be a super Kepler that will finally deliver the number of Earths in the universe. And so they are rapidly catching up and even exceeding our abilities in several fields. There has not been much collaboration between these different agencies.
Do you think they'll share it with you? Do you think they'll share it with you?
Yeah, I've certainly. I mean, it's almost the opposite. It's actually, hard to if you have a Chinese collaborator or a Chinese co-author on papers. NASA have all sorts of rules about being careful with that kind of stuff. So because they're very worried about spying on their agencies. So there's a deep level of distrust and very low cooperation at the moment. But obviously, the vast majority of scientists in astronomers in China just are the same as us. They're just interested in the same questions. They're not driven by agendas or motives. They don't really care what the government's saying. No. They just want to figure out, is there life in the universe? There's a huge number of people that feel the same way as us. And so I hope we can cooperate more with them, and we certainly have many incredibly intelligent and talented Chinese students come through Columbia that I know feel that same way.
If anything, the only reason I would think that they wouldn't is because they don't want to get hung over there.
Yeah, I mean,
unfortunately, really.
Yeah, there's definitely consequences for free speech in China, which is something that can interfere with science in certain cases. But hopefully we can at least, I think having healthy competition is probably good though. It's actually good to have some competition in the game. Europe's been our competition for a long time, but it's good to have even a third competitor and to keep us pushing the envelope. And sure, the US, let's try to make sure the US is the first ones to find the Earth-sized planet. And that should be an impetus to us to fund this stuff and to get there, and to either through collaboration or competition, I'm happy as long as we get to the goal.
Isn't that a shame? It's like China has to make all these advancements for the U.S. to fund ourselves to keep.
Yeah, I mean, but how would we, if we found aliens, we'd probably all start, the boundaries between nations would probably fall apart pretty quick, right? We'd probably all be like, actually, we should all just get together.
Yeah. On this one, okay. Yeah. Let's forget about the trade problem. Right. And, we have a nuke pointed at you, but right now, let's just forget about all that, right? There's this up.
Competition can sharpen the mind sometimes, right? So, sad but true.
So how can people find you? The website, YouTube, donate, all that stuff, Twitter? Are you mostly on Twitter?
Yeah, I'm David_Kipping on Twitter.
I've noticed that a lot of people just are done with the Instagram for the most. It's just like too much craziness.
Yeah, TikTok's saying it. Yeah, I don't do TikTok, I don't do Instagram, and I tweet occasionally. But
TikTok just started going through that flat Earth thing all day. But you have 27 messages about that.
Yeah.
All right, man. Well, thank you for your time, and I hope to see you again. I have 100 more questions for you, but don't want to kill you.
Yeah.
But thank you so much, man. It's an honor. Really to sit across from a guy like you. You're doing a great thing, and just wish you all success. And they spend double this time on the damn thing so we can see.
Yeah. Thank you so much, Tommy. It's really a pleasure to be on here. Thank you.
Thank you, man. This episode is sponsored by Aurora. Do you know what the fastest growing crime in America is? For years, this crime rate has been surging and affecting millions of Americans. I'm talking about identity theft, and there's a new victim every 14 seconds. Yet despite this, those who have had their identity stolen are often shocked when it happens. That's why I'm excited to partner with Aurora, who is sponsoring this video. Aurora is identity theft protection, fraud monitoring, a VPN, password management, and antivirus software all into one easy-to-use app. Their VPN allows you to stay anonymous online by keeping your browsing history and personal information safe and encrypted. Protect you and your family from America's fastest-growing crime. Try Aurora for free for 2 weeks and see if you or anyone in your family's personal information has been compromised. Start your free trial today. Go to aurora.com/MSCS. The link is in the description below.